Have you ever wondered what lies beyond the edge of everything we thought we knew about the universe? What if I told you that in the past few years, humanity has been quietly rewriting the fundamental story of cosmic existence, and most people have no idea it's happening? On Christmas morning back in 2021, the world watched in awe as the most powerful space telescope ever built launched into the stars. It took 30 years of planning, $10 billion, and the dedication of thousands of brilliant minds to bring the James Webb Space Telescope to life. That single launch was the start of a mission to completely change how we see the universe. If you enjoy these journeys into space and discovery, make sure to subscribe and turn on the bell so you don't miss what's next. Get ready, we're about to journey through some of the greatest space discoveries of our time. Close your eyes if you want, breathe in, and imagine drifting through the galaxy as we explore what the James Webb Telescope has uncovered. Tell me where you're tuning in from tonight, your city, your time. There's something powerful about knowing we're all scattered across Earth, yet sharing the same sky that Webb is helping us finally understand. But what makes Webb truly special? It's not just bigger mirrors or sharper cameras. It's rewriting the story of the cosmos. This telescope is our first real window into the dawn of the universe. A time machine looking back over 13 billion years to when the cosmos was just being born. From its orbit a million miles away, it's already rewriting textbooks, breaking old theories, and revealing cosmic wonders we never even imagined. These discoveries don't just push science forward, they reshape how we see our place in the universe. But here's something you might not expect. Webb doesn't orbit Earth like Hubble. Instead, it parks at a special point in space called L2, perfectly balanced between the pull of the Sun and Earth, protected by a sun shield the size of a tennis court. With insulation like SPF 1,000,000, it hides in deep darkness. Its instruments run colder than Pluto itself, all for one reason: to let us glimpse a universe that's still expanding. As light travels across the universe for billions of years, it stretches like a rubber band pulled to its limit. The glow from the earliest stars and galaxies has been stretched so far, it's no longer visible to our eyes, but Webb can see it perfectly in infrared. That means every time Webb looks deeper into space, it's actually looking further back in time, revealing the universe as it was when it was young. Think of it like cosmic archaeology, digging through layers of history older than Earth itself. And what Webb uncovered shocked even the most hopeful astronomers. Just months after starting in 2022, it sent back images that left scientists stunned. Then came the biggest surprise. In May 2024, Webb spotted a galaxy, JD's GSZ 140, glowing only 290 million years after the Big Bang. On a cosmic calendar, that would be like the universe forming on January 1st, and this galaxy appearing by January 8th. This galaxy isn't just a new record, it's a shock to our entire understanding of the early universe. By current theories, galaxies of this size and brightness shouldn't have had time to form so soon after the Big Bang, yet Webb found one. As Yale scientist Peter Van Dam explained, this is the most distant object ever detected, and the telescope wasn't even supposed to find galaxies this early in cosmic history. The implications are huge. The universe was organizing itself much faster and more efficiently than anyone imagined. Picture discovering that ancient civilizations not only built massive cities, but did it faster than we can today. And this galaxy wasn't alone. Webb has spotted whole groups of massive galaxies in the universe's first 700 million years. Some as heavy as the Milky Way itself. These discoveries shake the very foundations of our models of cosmic evolution. When Webb analyzed the light from some of the earliest galaxies, the results didn't match what anyone expected. Its instruments revealed high amounts of nitrogen, far more than we see in our own sun, while many other heavy elements were strangely lacking. This suggests the first stars weren't following the rules we thought they did. The process of forging elements and spreading them across the cosmos may have worked very differently in the universe's early days. Imagine uncovering evidence that ancient civilizations were making high-tech metals with methods we can't explain. That's how shocking this discovery is. Webb is proving our models of stellar evolution and galactic chemistry are missing big pieces of the puzzle. Our understanding of the cosmic processes that gave rise to worlds like Earth and life itself remains incomplete. Webb has added a new twist to the puzzle by uncovering galaxies in the early universe that look nothing like what astronomers expected. Instead of the familiar spirals and ellipticals that dominate the local cosmos, many of these ancient systems appear as flattened disks, elongated ovals, and even tube-like structures. This discovery was completely unforeseen and calls for much deeper investigation. It's as though we stumbled upon ancient architecture built under entirely foreign principles, structures that function perfectly and display their own kind of beauty, yet operate by rules we're only beginning to piece together. The implication is clear. Galaxy formation in the early universe did not always follow the paths laid out by our current theories. Yet Webb hasn't only revealed vibrant active galaxies from cosmic dawn, it has also identified their opposites, galactic corpses. These are systems that blazed with furious star formation, only to burn out quickly and fade into dormancy. They represent a kind of stellar overdrive, galaxies that lived fast and died young. While earlier telescopes had hinted at their presence, only Webb has the ability to analyze their light with enough precision to determine not just that they are dead, but how long they've been lying in cosmic silence. It's as if Webb has given us a cosmic forensics lab, one capable of telling us not just that a galaxy has died, but precisely when and how it met its end. These clues are rewriting our understanding of the life cycles of galaxies in the early universe. The scientists behind Webb's early observations have been very clear. This is revolutionary. As one researcher put it, before Webb, we simply did not have direct observational data to test our ideas about the physics of the early cosmos. Now, for the first time, the telescope is bridging the gap between the theoretical Big Bang and the vast collection of galaxies we see scattered across today's night sky. But these discoveries are also stirring up difficult questions. Cosmologists are now forced to confront the mysteries of dark matter, the efficiency of star formation at cosmic dawn, and even the timeline of evolution itself. Can our existing models be stretched to fit these surprising findings, or must they be fundamentally rewritten? The debate is ongoing. Some argue that early star formation was far more efficient than in the modern universe, allowing galaxies to grow massive in astonishingly short timescales. Others suspect that our understanding of dark matter, the invisible framework that shapes galaxies, may itself need revision. What is clear, however, is that Webb has given us something we've never had before. Real observational data from a time in cosmic history we could previously only guess at through equations and simulations. For the first time, we are seeing the universe as it truly looked in its youth. And the implications reach far beyond academic curiosity. These discoveries are reshaping humanity's origin story, the grand narrative of how the universe transformed from a hot, dense and simple beginning into the complex cosmic web we inhabit today. Studying these early epochs isn't just about curiosity or tracing our ancestry. It's about uncovering the very laws that govern how order emerges from chaos, how simplicity gives rise to complexity, and how the raw ingredients of stars, planets, and life itself were scattered across the universe. We now stand at the edge of a profound scientific turning point. What Webb is revealing may be the greatest shift in cosmology since Edwin Hubble showed that the universe was expanding. Its early findings prove that cosmic evolution happened faster, more efficiently, and in more dramatic ways than we ever thought possible. Yet these glimpses into the distant past are only the beginning of Webb's impact. The telescope's power stretches far beyond the realm of ancient galaxies. It is also opening windows onto worlds much closer to home, illuminating the mysteries of star birth, planetary formation, and even the conditions under which life might arise, both in familiar environments and on planets utterly alien. The saga of Webb's discoveries is still unfolding, with each new image and data set writing another chapter in the epic story of our cosmos. What we've seen so far is just the introduction. With its infrared vision, Webb is peering further back in time and deeper into space than any human-made instrument before it, shifting its gaze from the cosmic dawn to our own stellar neighborhood, and in the process revealing secrets that were hidden in plain sight. These are worlds that could, under the right conditions, nurture life itself. Imagine this: only 40 light-years away, a faint red dwarf star is orbited by 7 rocky planets so tightly packed that if you were standing on one of them, the others would loom in the sky larger than our own moon. This is the TRAPPIST-1 system, discovered in 2017 and instantly hailed as one of the most extraordinary planetary systems ever detected. Its allure lies not just in the sheer number of Earth-sized worlds it contains, but in the tantalizing possibility that some of them may orbit within the habitable zone, the region where liquid water could exist on their surfaces. Red dwarfs like TRAPPIST-1 are the most common type of star in the Milky Way. If planets orbiting such stars can sustain atmospheres and hold onto liquid water, then the number of potentially habitable worlds in our galaxy could be unimaginably vast. But there is a catch. Red dwarfs have a turbulent youth. They bombard their planets with powerful flares and radiation, raising the question of whether the TRAPPIST-1 worlds are barren, scorched rocks, or whether some have managed to cling to protective atmospheres. For years this mystery lingered, until Webb turned its gaze toward the system. With its unprecedented sensitivity, Webb has begun peeling back the veil. Using its mid-infrared instrument, the telescope achieved something once thought impossible: the first direct detection of thermal emission from a rocky planet comparable in size and coolness to those in our own solar system. The team targeted TRAPPIST-1b, the innermost world. By measuring its heat glow in infrared light, they found that the planet's day-side bakes at around 500 Kelvin, or roughly 450 degrees Fahrenheit, a milestone that opens the door to probing the conditions of Earth-sized exoplanets like never before. Webb's measurements indicated that TRAPPIST-1b does not possess a detectable atmosphere. This outcome underscores the vulnerability of terrestrial planets orbiting close to red dwarf stars, whose intense radiation can erode atmospheric gases over time, leaving behind a bare, overheated surface. The telescope then targeted TRAPPIST-1d, a planet located within a region of the system where liquid water could theoretically exist. Given its orbital position, TRAPPIST-1d was considered a prime candidate for retaining a stable atmosphere capable of supporting habitable conditions. However, Webb's spectroscopic observations provided no evidence for an Earth-like atmosphere around this world. As Caroline Plegg-Goep of the University of Chicago noted, while our long-term aim is to assess whether Earth-like environments can exist elsewhere, Webb's observations allow us to eliminate TRAPPIST-1d from consideration as a potential Earth analogue. Although these findings reduce the habitability prospects of 2 of the TRAPPIST-1 planets, they represent an important refinement of our understanding. Each null result constrains the models astronomers use to assess exoplanetary atmospheres and helps redirect the search toward worlds more likely to maintain the conditions necessary for life. A recent reanalysis of Webb's observations of TRAPPIST-1b has introduced new possibilities about the nature of this exoplanet. By applying different observational techniques across multiple wavelengths, researchers found indications that the planet may host a thin, carbon dioxide-rich atmosphere. Alternatively, the data may instead point to an unusually high surface temperature, consistent with geological activity such as ongoing volcanism that could replenish atmospheric gases even as stellar radiation strips them away. This case highlights one of Webb's core strengths, its ability to investigate distant planets using complementary methods that reveal different aspects of their environments, much like employing specialized instruments in a laboratory to study a complex sample. The insights drawn from TRAPPIST-1b contribute to broader questions of planetary habitability, particularly regarding how atmospheres are retained or lost in systems dominated by red dwarf stars. Such findings refine the criteria astronomers use to evaluate the potential for life-bearing planets across the galaxy. Webb's focus, however, is not limited to habitable zone planets. The telescope has also begun probing the most massive and enigmatic structures in the cosmos, supermassive black holes that occupy galactic centers and influence the evolution of their host galaxies. In the constellation Telescopium, Webb identified a compact red source dating to approximately 500 million years after the Big Bang. Analysis suggests this faint object harbors one of the earliest black holes ever observed, a discovery that challenges prevailing models of black hole formation and growth in the young universe. The supermassive black hole at the center of Galaxy Capers, LRDZ9, has an estimated mass of approximately 38 million solar masses, roughly 10 times greater than Sagittarius A star, the central black hole of the Milky Way. Remarkably, this early black hole comprises nearly 5% of the total stellar mass of its host galaxy, a proportion vastly higher than the approximately 0.1% typically observed in the present-day universe. According to Stephen Finkelstein, this observation supports growing evidence that black holes in the early universe either experience much faster growth than current models predict, or originated with significantly higher initial masses. Such findings challenge our understanding of how matter can be accreted efficiently under extreme gravitational conditions. Webb further detected the most distant black hole merger on record. In May 2024, the telescope identified two massive black holes in the process of merging within the galaxy system ZSS7, occurring approximately 740 million years after the Big Bang. Black hole mergers release enormous energy in the form of gravitational waves, exceeding the total light output of all observable stars. The presence of such mergers so early in cosmic history indicates that supermassive black holes achieve substantial mass rapidly through both accretion and frequent collisions. Additionally, Webb's observations suggest the existence of direct collapse black holes, which form through the sudden collapse of massive gas clouds rather than through gradual stellar evolution. Among these, the Infinity Galaxy stands out, exhibiting two compact red nuclei surrounded by rings that resemble the mathematical infinity symbol. These findings provide critical insights into the formation and evolution of the first supermassive black holes in the universe. This strange and mesmerizing structure seems to have formed from the head-on collision of two disk galaxies. Yet what truly captures the imagination is the supermassive black hole nestled between the two nuclei, embedded within a vast cloud of gas. Researchers propose that this black hole may have arisen through the direct collapse of the surrounding gas itself, a cosmic shortcut that could explain how some of the enormous black holes Webb has uncovered in the early universe grew so rapidly. Instead of a slow accumulation from smaller stellar remnants, These objects may have begun life already weighing millions of times more than our Sun. It's like discovering that some mountains weren't slowly built by geological forces, but were instead dropped fully formed from the heavens. Webb's revelations get even more extreme. Observations combined with Chandra X-ray data revealed a low-mass supermassive black hole just 1.5 billion years after the Big Bang, consuming matter at over 40 times the theoretical limit. This super Eddington accretion occurs when a black hole feeds faster than radiation pressure should allow, akin to finding a drain that empties a bathtub faster than water can flow in, defying the very rules of physics. Haewon Soo of the International Gemini Observatory explained that such brief but intense feeding frenzies could account for much of a black hole's mass growth, regardless of whether it began as a light or heavy seed. These discoveries go far beyond individual objects. They reveal that supermassive black holes were already shaping their host galaxies very early in cosmic history, playing a critical role in structuring the universe itself. As Webb peers ever deeper into space and further back in time, it continues to show us that the early cosmos was anything but simple or static. Massive structures emerged with startling speed and efficiency, transforming our view of the young universe. And these black hole revelations are only part of Webb's broader revolution. The telescope's extraordinary versatility allows it to study everything from tiny brown dwarfs to the largest cosmic structures, each observation adding vital pieces to the story of how the universe evolved. And the adventure doesn't end there. The journey takes us beyond the familiar boundaries of our own galaxy into realms previously unimaginable. For decades, astronomers have identified thousands of brown dwarfs, objects that occupy the mass range between planets and stars. While too massive to be classified as planets, brown dwarfs lack the sustained nuclear fusion that defines true stars. These objects have been observed primarily within the Milky Way. Webb, however, detected the first significant population of brown dwarf candidates outside our galaxy, located within the star cluster NGC 602. According to Elena Mangjavarkas of the Space Telescope Science Institute, this discovery extends our knowledge beyond the approximately 3,000 brown dwarfs previously catalogued exclusively within the Milky Way. Studying these young, metal-poor brown dwarfs in an extragalactic environment provides critical insights into star and planet formation under conditions distinct from our local neighborhood. Webb further identified the smallest free-floating brown dwarf on record, with a mass of only 3 to 4 times that of Jupiter. Kevin Luhman of Pennsylvania State University noted that this discovery addresses a fundamental question in astrophysics. What constitutes the minimum mass for stellar formation? Along with 2 additional ultra-low mass objects identified in the same survey, this brown dwarf defines the extreme lower limits of formation via star-like processes. These low-mass, cool objects occupy the transitional zone between failed stars and massive planets, challenging conventional models of gravitational collapse and stellar formation. Webb has also observed brown dwarfs with protoplanetary disks, including 20 confirmed cases in the Orion Nebula. These findings demonstrate that even low-mass brown dwarfs can retain sufficient material for planet formation, contradicting previous models that suggested they would be incapable of sustaining such disks. Overall, Webb's observations revealed that the processes leading to planetary system formation may be more common and diverse than previously understood. Webb's findings suggest that the processes leading to planetary formation may be widespread, extending even to brown dwarfs. If such low-mass objects can host planets, the total number of potentially habitable worlds in the galaxy may be considerably larger than previous estimates. The telescope's capabilities also apply to objects within the solar system. In December 2024, asteroid 2024 YR4 was discovered, with a small but non-zero probability of Earth impact in 2032. Assessing its hazard requires an accurate measurement of its size, which cannot be reliably inferred from visible light brightness alone. Depending on albedo, a small reflective asteroid may appear as bright as a larger, darker one. Estimates place 2024 YR4 between 40 and 90 meters in diameter, a range critical for evaluating potential impact effects. Webb's infrared measurements provide thermal emission data, enabling precise size determination and improved assessment of the asteroid's potential threat. Beyond planetary defense, Webb has observed interstellar objects such as Comet 3 I/Atlas. These bodies, originating outside the solar system, carry material formed around other stars, offering unique insights into the composition and conditions of distant planetary systems. Because they transit the solar system only briefly, Webb's observations allow astronomers to study these interstellar visitors with unprecedented detail, effectively conducting remote chemical and structural analysis without interstellar travel. Additionally, Webb has examined some of the most complex and visually intricate structures within our local cosmic neighborhood, contributing to a broader understanding of the formation and evolution of stars, planets, and other nearby celestial phenomena. Webb's observations of interstellar dust and gas revealed remarkably intricate structures resembling knots and whorls that had never been resolved at such detail before. Jacob Jensen of Caltech, principal investigator of one study, noted the team's astonishment at the unprecedented clarity. Layered formations resembling the structure of an onion were observed, providing a first detailed three-dimensional mapping of the interstellar medium and insight into how matter organizes and flows in the spaces between stars. Within the solar system, Webb has offered new perspectives on familiar planets. Observations of Jupiter expose previously unrecognized features above the Great Red Spot, a region once considered relatively quiescent, while infrared imaging captured auroral activity caused by interactions between the planet's magnetic field and charged particles from the Sun. Webb has also provided critical data on Saturn's moon Titan, whose dense nitrogen-methane atmosphere had previously obscured detailed study. By combining Webb's observations with ground-based data, scientists detected evidence of cloud convection in Titan's northern hemisphere, the region containing most of the moon's lakes and seas, likely replenished by episodic methane and ethane precipitation. The telescope also identified key carbon-containing molecules, providing insight into Titan's methane cycle, an analog to Earth's water cycle operating at much lower temperatures. These observations extend beyond planetary science, offering insight into chemical processes that may occur on other extreme worlds in the galaxy, where liquid water is absent. But alternative chemistries may support complex molecular formation. Across its studies, from the most distant galaxies to local planetary bodies, Webb demonstrates the iterative nature of scientific exploration. Each discovery builds upon existing knowledge while generating new questions previously unrecognized. The telescope is showing us that the universe is connected in ways both complex and beautiful. The same rules that shape the first galaxies also guide the way dust moves in nearby clouds. The same forces that create heavy elements in the hearts of stars also shape the asteroids and rocks in our own solar system. Webb is teaching us that astronomy isn't just about counting stars or mapping galaxies. It's about seeing the invisible threads that connect everything, from the smallest specks of matter to the largest cosmic structures. Each discovery adds a new thread to this vast cosmic tapestry, revealing patterns and relationships that hint at a deeper unity in the universe. As we follow Webb's journey, we find ourselves learning not just new facts, but new ways of thinking about our place in the cosmos. The universe is both strange and familiar, simple yet incredibly intricate, with hidden beauty waiting to be discovered at every scale. And this story is only beginning. Each day brings new images, new data, and new secrets, challenging what we thought we knew and expanding our understanding. Webb peers deeper into space and further back in time than any telescope before it, uncovering mysteries that lie between the familiar and the utterly alien. In distant clouds where new stars are born, Webb reveals cosmic nurseries filled with swirling gas and dust. Here, baby stars take their first breaths, surrounded by disks that will one day form planets, moons, and the building blocks of life itself. The telescope has shown these nurseries in incredible detail, uncovering jets of hot gas shooting outward from newborn stars. Invisible to our eyes, but glowing brightly in infrared light, these jets carve paths through surrounding clouds, shaping the very environments where future worlds will emerge. Every jet tells a story of balance, a young star regulating its own growth, shedding excess material that might otherwise make it collapse under its own weight. This delicate cosmic dance decides whether a star will live a long, stable life capable of hosting planets, or burn out quickly in a short, spectacular blaze. Webb's most haunting discoveries come from regions where stars have already completed their life cycles. Massive stars, after exhausting their fuel, do not simply fade away. Instead, they explode in brilliant supernovas, scattering the heavy elements created in their cores across vast stretches of space. Webb has captured these stellar deaths in exquisite detail, revealing glowing shells of gas enriched with the very elements that make planets, oceans, and life itself possible. Through these observations, Webb shows us the story of creation and destruction on a cosmic scale. It reveals how matter organizes, evolves, and transforms, from the birth of stars in quiet clouds to the violent deaths that seed the universe with the ingredients for new worlds. Each observation is a glimpse into a universe that is alive with motion, energy, and creativity. A universe where even the smallest events play a role in shaping the grand design. The telescope teaches us that the cosmos is a living, breathing tapestry where patterns repeat across scales and where every star, cloud, and planet is connected by the same natural laws. It is a universe that is at once understandable and endlessly mysterious, offering moments of awe, calm, and quiet reflection. As Webb continues its journey, we are invited to witness the unfolding story of the cosmos, a story of light and shadow, birth and death, chaos and harmony. And as we drift among these thoughts, imagining the silent dance of stars and the gentle glow of distant clouds, we are reminded of our own small place in this vast, interconnected universe, where beauty, complexity, and wonder are woven into every corner of existence. Carbon, oxygen, silicon, iron, the very materials that form planets and life itself, are scattered across the universe by the deaths of stars. Webb has captured these cosmic legacies in stunning detail. In one moving observation, the telescope revealed the remnant of a supernova that exploded centuries ago. Its expanding shell of glowing debris still radiates the heat of its violent birth. And yet, within this cosmic graveyard, new stars are already forming, nourished by the enriched material left behind by their stellar ancestors. It's a beautiful reminder that in the universe, death and birth are intimately linked, dancing together in a cycle of endless renewal. Webb has also shown us that these stellar explosions do more than simply blast material outward. They carve intricate three-dimensional structures, channeling heavy elements along cosmic highways, guiding them toward regions where new stars and planets can form. These patterns help explain how planets like Earth acquired the diverse chemical ingredients needed for geological complexity and life. Webb's vision extends beyond single stars to entire ancient stellar populations, like globular clusters, cosmic cities of stars formed when the universe was young. These clusters hold some of the oldest stars in the galaxy, time capsules preserving the chemical story of the cosmos. By studying their light, astronomers can trace how generations of stars were born and died, gradually enriching the galaxy with the elements needed to form planets and eventually life itself. Perhaps the most profound discoveries come from the cold, dark spaces between stars. Webb has detected complex carbon-based molecules floating in these frigid regions, molecules that serve as the building blocks of biology. These organic compounds form slowly over millions of years on icy dust grains, and when new stars awaken and heat their surroundings, the molecules are released into space, ready to become part of future planetary systems. Planets may begin their lives already seeded with the ingredients for life. Webb has even traced these molecules to the atmospheres of distant exoplanets. The telescope can detect the chemical fingerprints of water vapor, carbon dioxide, and organic compounds on worlds orbiting stars far from our own. In one intriguing example, Webb found such molecules in the atmosphere of a planet around a sun-like star. Though this world is too hot to support life as we know it, the discovery shows that the basic ingredients for biology can survive the violent process of planetary formation, remaining available for life to emerge elsewhere. These studies mark a new frontier in our search for life. By examining exoplanet atmospheres, astronomers can begin to pinpoint worlds where conditions might support biology. But Webb has also revealed how fragile these conditions can be. Some exoplanets have lost most of their atmospheres to harsh stellar radiation, leaving behind barren rocks that may once have had the potential for life. Webb has also observed rogue planets, lonely worlds ejected from their original solar systems, wandering through the darkness of space. Even in isolation, these planets carry clues about how planets form, evolve, and survive in the vast cosmic landscape. Through all these observations, Webb reminds us that the universe is a living story, one of creation, transformation, and delicate balance. It is a cosmos where the cycles of birth and death, of chaos and order, continually weave the fabric of everything we see and everything we are. These orphaned worlds drift silently through space, invisible to ordinary telescopes because they give off no light of their own. Yet Webb can detect their faint glow in infrared light, revealing planets wandering alone through the void. Their existence shows that planetary formation is far more chaotic than we once imagined. During the early stages of a star system's birth, gravitational forces can fling planets into interstellar space, where they may drift for eternity, untethered to any star. Some of these rogue planets could still harbor internal heat, creating hidden oceans beneath frozen surfaces, mysterious habitats for life existing entirely independent of a sun. These dark, lonely worlds challenge our traditional ideas of habitability, suggesting that life might survive in places we had never considered. Webb's gaze has also revealed the incredible variety of planetary systems throughout the galaxy. Unlike our own solar system, where rocky planets sit close to the sun and gas giants dwell farther out, many systems appear almost random. Webb has observed massive planets racing so close to their stars that they complete full orbits in just days. In other systems, planets are locked into intricate gravitational dances, their orbits synchronized like cosmic clockwork. These diverse arrangements show that planetary formation is influenced by countless factors. The composition of the stellar nursery, the timing of formation processes, and random gravitational encounters that can reshape entire systems. Each planetary system tells its own story of cosmic evolution. By studying these unique configurations, Webb helps us understand why our solar system formed the way it did. The orderly spacing of planets, with rocky worlds near the Sun and gas giants farther out, is just one possibility among many paths that planetary evolution can take. Webb has also turned its attention closer to home, revealing new details about the moons of our solar system's giant planets. Observations of Jupiter's moons show geological activity more dynamic than we realized. Io, the most volcanically active body in the solar system, is constantly reshaping itself with eruptions of molten rock. Europa, Jupiter's icy moon, reveals plumes of water vapor rising from its frozen shell, offering direct clues about the hidden ocean beneath. These plumes provide a way to study Europa's chemistry without drilling through kilometers of ice. Saturn's moon, Enceladus, has also revealed surprising secrets. Webb has detected complex organic molecules in its subsurface ocean, hinting that this distant frozen world contains the essential ingredients for life. These observations show that even far from the warmth of a sun, planets and moons can harbor dynamic, potentially habitable environments. Through all of this, Webb teaches us that planetary systems are incredibly diverse, mysterious, and full of surprises. From lonely rogue worlds drifting in darkness to icy moons hiding oceans beneath frozen surfaces, the telescope unveils a universe rich with possibilities, where life might find a way in even the most unexpected places. The discovery of these compounds in the plumes of Enceladus hints at the possibility of life in places very different from Earth. These icy moons across our solar system may be among the most promising locations to search for living processes. Instead of looking only at planets orbiting within their star's habitable zone, astronomers are realizing that moons with hidden oceans could also host life. Webb's observations show that liquid water, a key ingredient for life, might be much more common in the galaxy than we once thought. Tidal heating from massive parent planets can keep these subsurface oceans liquid for billions of years, creating stable, long-lasting environments where life could potentially emerge. Webb has also revealed surprising details about comets, the ancient travelers that preserve materials from the earliest days of our solar system. By analyzing comet atmospheres, the telescope has detected complex organic molecules that formed in the frigid outskirts of the young solar system. These comets act as time capsules, carrying pristine samples of the raw materials that shaped Earth and the other terrestrial planets. Among these molecules are compounds essential for life as we know it. This supports the idea that comets may have delivered key chemical ingredients to Earth during the late heavy bombardment, when ancient objects collided with the inner planets. Webb's findings suggest that the line between astronomy and biology is far more connected than we once imagined. The chemical processes that lead to life operate across the cosmos, from the cold depths of interstellar space to the surfaces of planets and moons that could support biology. As we follow these links between star formation, planetary evolution, and the emergence of life, we begin to see that our existence is not a random accident, but part of a vast cosmic network. Each observation adds another piece to this immense puzzle, revealing hidden connections and patterns that show how everything in the universe is interrelated. Webb is teaching us that we are not separate from the universe, but deeply connected to its most fundamental processes. The telescope continues to push the limits of what we thought was possible, uncovering phenomena that challenge our ideas and expand our imagination, showing us a cosmos that is alive with complexity, wonder, and endless possibilities. Each new discovery opens doors to questions we hadn't even thought to ask, ensuring that the journey of exploring the universe will continue for generations to come. As Webb peers deeper into space and further back in time, it carries with it our curiosity, our wonder, and our deep human desire to understand our place in this vast cosmic story. What we've explored tonight is only the beginning of what promises to be one of the most remarkable eras of astronomical discovery in human history. The telescope's gaze stretches towards some of the universe's most mysterious objects, uncovering secrets that exist at the very edges of our understanding. In the hearts of active galaxies, where supermassive black holes devour matter with an almost unimaginable hunger, Webb has observed jets of material shooting outward at nearly the speed of light. These cosmic fountains, stretching across distances that dwarf entire star systems, are among the most powerful forces in the universe. What makes these observations truly extraordinary is not just their scale, but the precision with which Webb can study them. The telescope can trace individual knots of matter as they race along these jets, revealing how energy and material behave under conditions that exist nowhere else in nature. These jets act as cosmic laboratories, testing the laws of physics to their absolute limits. The material within experiences gravitational fields billions of times stronger than anything on Earth, temperatures hotter than stellar cores, and magnetic forces so immense they influence matter across light years. By observing these extreme environments, astronomers are exploring the boundaries of relativity, quantum mechanics, and plasma physics in ways no Earthbound laboratory could replicate. But some of Webb's most haunting discoveries come from regions where galaxies themselves are fading. In the universe's cosmic graveyards, the telescope has witnessed the final moments of galactic evolution, where star formation has ceased and entire stellar populations are slipping into darkness. These galactic fossils tell stories of cosmic violence and renewal spanning billions of years. Some galaxies die quietly, slowly exhausting their star-forming gas until no new stars ignite. Others meet violent ends, torn apart by gravitational encounters or consumed by ravenous central black holes. In one particularly moving observation, Webb captured a galaxy slowly being dismembered by a larger neighbor. Streams of stars, gas, and dust stretch between the two galaxies like delicate cosmic bridges, carrying the smaller galaxy's substance into the gravitational embrace of its massive companion. This celestial cannibalism is one of the fundamental processes shaping cosmic evolution, as larger galaxies grow by consuming smaller ones, a process that continues even today. Webb allows us to witness this cosmic recycling in stunning detail, observing matter flowing from one galaxy to another across unimaginable distances. Yet even in destruction, there is beauty. When galaxies collide and merge, the gravitational chaos sparks spectacular bursts of star formation. Webb has observed these stellar baby booms with unprecedented clarity, seeing how the violent mixing of galactic material creates perfect conditions for new generations of suns. In these starburst regions, stars form hundreds of times faster than in calm galaxies, like our own Milky Way. A planet within such a system would see its night sky ablaze with the light of countless newborn stars, creating displays of unimaginable brilliance. These starburst galaxies shine intensely but briefly in cosmic terms. Their rapid star formation consumes raw materials within just a few million years, leaving behind massive stars destined to explode as supernovas in relatively short order. Webb's infrared vision, allows it to peer through the thick clouds of dust that cloak these stellar nurseries, revealing spiral patterns, shock waves, and turbulent flows that sculpt star-forming material with intricate and almost artistic precision. These observations reveal that even in the most chaotic corners of the cosmos, nature creates patterns of surprising regularity and elegance. Gravity, magnetism, and fluid dynamics work together to shape matter into structures as mathematically precise and beautiful as any artwork crafted by human hands. Webb has also made groundbreaking discoveries about the invisible influence of magnetic fields across space. These unseen forces stretch across vast regions, gently guiding the flow of matter and energy throughout the universe. By observing how light becomes subtly polarized as it passes through distant regions, Webb can detect the fingerprints of these magnetic fields. In star-forming clouds, they act like cosmic shepherds, directing the collapse of gas and dust, and shaping where and how new stars will take their first breaths. In the expanses between galaxies, these same fields organize matter along the cosmic web, the vast network of dark matter filaments that connects clusters of galaxies across unimaginable distances. Understanding the role of these magnetic forces has profound implications for how the universe evolved, from the smooth early conditions after the Big Bang to the intricate structures we see today. Webb has revealed unexpected connections between the very largest and the very smallest scales in the cosmos. The telescope's observations show that the same principles that govern the behavior of individual atoms also influence the evolution of entire galaxy clusters over billions of years. Quantum effects operating on subatomic scales subtly shape the motion of matter in the almost empty spaces between galaxies, while gravitational forces, which dominate the largest cosmic structures, also control the flow of material within individual stellar systems. These links suggest that the universe functions as a unified whole, where phenomena across vast differences in scale are intimately connected through the fundamental laws of physics. Webb is unveiling a cosmos that is both astonishingly complex and deeply comprehensible, a universe where order emerges from apparent chaos. The telescope has also shed new light on one of the universe's greatest mysteries: dark matter. This elusive substance outweighs ordinary matter by a factor of 5, yet it neither emits nor absorbs light. Webb, however, can sense its presence through the subtle ways it bends and shapes the matter around it. In galaxy clusters, the largest structures in existence, the telescope has revealed how dark matter molds ordinary matter into intricate patterns, guiding the growth and arrangement of galaxies across cosmic time. By observing slight distortions in the shapes of distant galaxies, caused by the gravitational lensing effects of dark matter, Webb provides vital insights into the properties and behavior of this invisible cosmic scaffolding. Through these discoveries, the telescope is showing us a universe where the hidden and the visible, the immense and the minuscule, are all part of a single interconnected tapestry. Every filament, every magnetic wave, every ripple in space-time reveals a story of cosmic harmony, a universe that is far more intricate, beautiful, and interconnected than we ever imagined. These cosmic mirages allow astronomers to trace the invisible threads of dark matter that weave through the universe with astonishing precision. These maps reveal a cosmos shaped by vast networks of unseen scaffolding, guiding ordinary matter into the stars and galaxies we can observe. It's as if the landscape we thought we knew is actually supported by a hidden architecture, invisible yet fundamental, determining the placement of every star, every spiral arm, every glowing cluster. Webb's observations are also shedding light on the mysterious force of dark energy, the subtle power that drives the accelerating expansion of the universe. By watching how cosmic structures have changed over billions of years, the telescope provides new insights into this elusive energy. The expansion of space itself gently stretches the light traveling from distant galaxies, and Webb can measure these effects with extraordinary sensitivity, revealing how dark energy has shaped cosmic evolution throughout the ages. These measurements suggest that dark energy's influence has not been constant, but has shifted over time, hinting at a universe whose destiny may be more intricate and dynamic than we ever imagined. As Webb continues its observations, it is becoming clear that we are witnessing more than isolated discoveries. We are witnessing a profound transformation in our understanding of the universe itself. The cosmos operates through principles of connection and relationship, linking phenomena across all scales of space and time. Every observation builds on the last, while simultaneously opening doors to entirely new questions. The universe is not a collection of separate objects, but a unified system. Everything influences everything else through networks of forces and interactions that span the observable cosmos. The discoveries we've explored tonight are more than scientific milestones. They are glimpses into the very nature of existence. They reveal how complexity arises from simplicity, how order emerges from chaos, and how the fundamental forces of nature conspire to create a universe capable of contemplating itself. Webb is showing us that we are not merely spectators of the cosmos. We are participants in its ongoing story. The atoms in our bodies were forged in the cores of stars. The energy that powers our thoughts flows from nuclear reactions within the sun. The gravitational forces that hold us to Earth reach outward, linking us to the farthest galaxies. As the telescope continues its revolutionary survey, each new observation adds another thread to the vast tapestry of cosmic understanding. We are witnessing the birth of a new era of astronomy, one that uncovers connections between phenomena once thought separate, revealing the subtle harmony that underlies the entire universe. Webb's journey has only just begun. Each day brings new revelations, challenging our assumptions and expanding our view of the cosmos. What we've explored tonight is only a fraction of the extraordinary insights this remarkable telescope will provide over its lifetime. The voyage continues, guiding us deeper into the mysteries of space and time, unveiling truths about the universe that will forever transform how we see ourselves and our place within this grand, unfolding cosmic story. Webb is not simply revealing what the universe looks like. It is showing us what the universe means and how every stage of cosmic evolution has led to the remarkable emergence of consciousness, minds capable of reflecting on their own origins. In the quiet darkness of space, millions of miles from Earth, this extraordinary telescope continues its patient work, collecting photons that have traveled across billions of years of cosmic history. Each tiny particle of light carries stories from times so distant that they existed before our sun was born, before our galaxy took its familiar shape, before the conditions for life had even begun to emerge. Yet, through the remarkable convergence of human curiosity and cosmic circumstance, we find ourselves able to capture and interpret these ancient messengers. Webb is the culmination of countless dreams and aspirations, a testament to humanity's irrepressible desire to understand the universe that gave birth to us. With each observation, the telescope adds a new chapter to the greatest story ever told. The story of how the cosmos evolved from simplicity to complexity, from darkness to light, from silence to the emergence of minds capable of wonder. Within this ongoing story, we find more than scientific knowledge. we find a profound sense of our place in the vast, interconnected web of existence. The revelations streaming from Webb are painting a picture of cosmic evolution that is both more violent and more beautiful than we could have imagined. As the telescope peers into the farthest reaches of space and time, it uncovers processes that operated when the universe was barely recognizable compared to the cosmos we inhabit today. In those primordial epochs, when the universe was still finding its rhythm after the chaos of creation, Webb has observed phenomena that challenge our most fundamental assumptions about how cosmic structures form and evolve. The telescope has detected what appear to be fully mature stellar systems existing at times when our models suggest they should still be in their infancy. These ancient stars shine with chemical signatures that seem almost impossible given the brief cosmic moment in which they formed. The heavy elements revealed in their spectra should have required countless cycles of stellar birth, death, and rebirth to accumulate. Yet here they are, lighting up the cosmic dawn when the universe was only beginning to learn how to make stars at all. It's like stumbling upon a master craftsman's workshop in a newly founded settlement, filled with tools and techniques that should have taken centuries to develop. The implications ripple through our understanding of stellar evolution, hinting that the early universe may have operated under rules we are only beginning to recognize. Even more intriguing are Webb's observations of the cosmic voids, those vast, seemingly empty regions between the great filaments of the cosmic web. For decades, these spaces were thought to be barren deserts of the universe, places where little of interest occurred. Yet Webb has revealed that even these emptiest expanses harbor subtle but profound mysteries. Within these cosmic deserts, the telescope has detected faint streams of matter flowing along invisible gravitational currents, like hidden rivers running through a landscape we cannot see. These streams suggest that even the most apparently empty regions are threaded with dark matter filaments, forming pathways along which ordinary matter can travel across unimaginable distances. Rather than simply falling toward massive galaxies under gravity, material appears to move along elaborate cosmic highways stretching hundreds of millions of light years. These transit routes help explain how galaxies can maintain steady supplies of gas and dust for star formation over billions of years. Webb has also observed that matter traveling along these invisible channels doesn't remain passive. Streams of gas heat up as they flow, glowing with thermal radiation that hints at compression and acceleration by forces we are only beginning to understand. This process has profound consequences for galactic evolution. As fresh material arrives at star-forming regions, it may become too hot to condense into new stars, limiting the pace at which galaxies can grow and develop. The cosmic web is not merely a backdrop for the universe. It is an active participant in shaping the evolution of matter and complexity. The telescope's gaze extends beyond individual structures to reveal the universe's overall architecture in 3 dimensions, with unprecedented clarity. These cosmic surveys show the large-scale structure of the cosmos resembles a vast living organism, with dense nodes connected by filamentary networks pulsing with flows of matter and energy. The resemblance to neural networks or circulatory systems is so striking that some astronomers wonder whether the universe itself may follow principles of organization we are only beginning to comprehend. The implications are both humbling and inspiring. If the cosmos naturally organizes itself in patterns resembling biological systems, it suggests that the emergence of life and intelligence may not be accidents, but natural outcomes of the universe's tendency to create increasingly complex order. Webb has also uncovered the subtle ways information flows throughout the cosmic web. The telescope can detect correlations in the properties of galaxies separated by vast distances. revealing that the universe is not a collection of isolated islands, but a connected, dynamic system where events in one region ripple across the cosmos. The telescope has revealed patterns in the cosmos that suggest distant systems may be connected in ways that transcend what we thought was possible. Correlations appear between regions so far apart that light itself could not travel between them fast enough to coordinate their behavior. These mysterious, almost quantum-like links challenge our understanding of cause and effect, hinting that the universe might communicate across vast distances in ways we are only beginning to imagine. Some scientists wonder if this cosmic interconnectedness could be a large-scale echo of quantum entanglement, where particles once in contact remain mysteriously linked regardless of the distance between them. If such processes exist on a cosmic scale, it implies a profound unity to the universe, a connectedness that stretches across space and time itself. As Webb continues to explore these mysteries, each observation raises new questions about the nature of reality. The telescope is revealing a cosmos that operates according to principles of connection and relationship, principles that we are only just starting to perceive. These insights extend even to our understanding of time. Webb's observations suggest that cosmic evolution does not proceed at a steady, predictable pace. Instead, the early universe seems to have experienced bursts of rapid development, interspersed with stretches of calm. These temporal fluctuations suggest the universe may grow in fits and starts, almost like a living organism, rather than evolving at a constant, measured rate. Webb has detected signs of ancient cosmic upheavals, events that temporarily disrupted the flow of galactic evolution. Collisions of black holes, the merging of dark matter structures, and other dramatic events may have triggered periods of intense activity, followed by long intervals of quiet recovery. Understanding these rhythms could help us anticipate the universe's future, whether our present moment is one of calm before another cosmic surge, or the start of a long, gradual decline. Perhaps most mind-stirring are Webb's discoveries that hint the universe might possess a form of memory. The telescope has observed correlations linking the properties of cosmic structures to events that happened billions of years ago, as if the cosmos remembers its own past. These memories seem encoded in the distribution of matter, the spins of galaxies, and the chemical makeup of stars, preserving records of ancient events within the very fabric of space and time. If the universe can retain information in this way, it raises astonishing possibilities. Consciousness and information processing may be fundamental features of reality, woven into the cosmos itself, rather than emerging solely from biological life. Webb has also detected structures that behave in ways reminiscent of neural networks, with activity flowing along cosmic filaments, as though the universe itself were thinking, or at least processing, information. While this does not prove that the universe is conscious in any ordinary sense, it suggests that the boundary between mind and matter may be more fluid than we have imagined. The same principles that give rise to thought in brains might also operate throughout the cosmos on scales far beyond our everyday experience. As we contemplate these discoveries, we are drawn into questions that reach far beyond astronomy, touching the very nature of existence. Webb is showing us not just what the universe contains, but what it might truly be, how consciousness, information, and matter may all be interconnected, and how our own awareness may resonate with the vast, intricate networks operating across space and time. The telescope continues its quiet watch, each new observation adding layers to our understanding of the cosmos. We are witnessing not just discoveries, but the unfolding of entirely new ways to think about reality, consciousness, and our place in the grand cosmic story. These insights gently transform how we perceive ourselves and our connection to the universe. Rather than being distant observers studying a foreign world, we are beginning to see that we may be an integral part of a vast cosmic system of information and energy, temporary arrangements of matter capable of reflecting on their own existence. Webb's discoveries suggest that the universe has been preparing for consciousness from its earliest moments, shaping matter and energy into forms capable of self-awareness and cosmic contemplation. We are not accidents in a random cosmos. We may be natural outcomes of the universe's inclination to create ever more intricate structures. Each new observation reveals connections between phenomena that at first seem unrelated, showing that every stage of cosmic evolution contributes to an overarching story of growing complexity and awareness, from the formation of the first atoms to the emergence of beings able to build instruments like Webb. The universe appears to be engaged in a quiet, ongoing project of self-discovery. As Webb peers further into space and deeper into time, it carries not just our curiosity, but our most profound questions about purpose, meaning, and connection. The telescope represents humanity's most ambitious attempt to understand not just what we are, but why we exist, and how our lives are woven into the vast tapestry of the cosmos, stretching from the Big Bang to the present moment. The journey of discovery continues, each observation adding new chapters to the greatest story ever told. The story of how the universe gave rise to minds capable of understanding their own origins. In that story, we find more than knowledge. We find a sense of belonging to something magnificent, mysterious, and profoundly meaningful. A story that stretches across all of space and time. Tonight, as you drift into sleep, imagine Webb continuing its patient work in the darkness, capturing ancient light that carries secrets of our deepest origins. The telescope acts as our ambassador to the cosmos, reaching across impossible distances to touch the foundations of existence itself. Each photon it gathers has traveled billions of years, carrying glimpses of places and times that existed long before our solar system was even a whisper in a cloud of interstellar gas. Yet through Webb's extraordinary vision, we can decode these ancient messages, slowly reconstructing the story of how everything we know and love came to be. The discoveries we have glimpsed tonight are only the beginning. Over the coming years, Webb will reveal wonders we cannot yet imagine, answer questions we never thought to ask, and uncover mysteries we never suspected existed. And perhaps its greatest gift is not just the discoveries themselves, but the sense of wonder and connection they inspire. Through Webb, we come to understand that we are not separate from the universe we study, but active participants in its ongoing journey of self-discovery and evolution, forever linked to the vast cosmic story that surrounds us. In the gentle darkness surrounding you, remember that you are made of elements forged in the hearts of ancient stars, arranged in patterns complex enough to reflect on their own cosmic story. You are the universe becoming aware of itself, a fleeting bloom of consciousness in the vast garden of existence. The cosmic story continues to unfold around us, through us, and within us. Webb serves as our window into that grand narrative, showing how every atom, every star, every galaxy contributes to the magnificent tapestry of existence that we are all part of. Rest now, fellow traveler of the cosmos, knowing that tomorrow will bring new revelations about the extraordinary universe we call home. As we drift deeper into Webb's discoveries, we encounter phenomena that challenge not just our scientific understanding, but our very sense of what it means to exist in this vast expanse. The telescope has begun to detect events that reside at the intersection of the physical and the profound, revealing patterns that hint at mysteries we are only starting to glimpse. In the farthest reaches of observable space, Webb has identified structures that seem to defy our understanding of how information can travel across the universe. Vast chains of galaxies, separated by distances so immense that light takes hundreds of millions of years to cross between them, display coordinated behavior that unfolds in perfect synchrony. These cosmic dances suggest that the universe maintains coherence on scales far beyond human imagination. It is as if musicians separated by continents can somehow play in perfect harmony without any apparent communication. The implications ripple through our understanding of cosmic evolution. If such distant regions of space can maintain coordinated development, it suggests the universe operates as a unified system in ways we are only beginning to appreciate. The familiar boundaries between here and there, between cause and effect, begin to blur when we consider phenomena unfolding on such immense scales. Webb has also revealed the persistence of cosmic patterns. The telescope has observed spiral structures in galaxy clusters that mirror the spiral arms of individual galaxies, as if the same organizing principles operate across scales that differ by millions of times. These nested patterns hint at a kind of cosmic fractal geometry, where similar forms repeat at vastly different scales. More mysteriously, Webb has detected ancient spiral patterns that have maintained their structure for billions of years, far longer than any known physical process should allow. These enduring geometries challenge our understanding of how cosmic structures evolve, suggesting that some aspects of universal organization possess a stability that transcends the typical life cycles of stars and galaxies. Webb's observations extend beyond the visible. The telescope can trace the invisible networks that connect everything in the cosmos, detecting the subtle gravitational currents flowing between distant objects. These hidden flows reveal that space is not empty, but a dynamic medium through which influence and information move in patterns of breathtaking complexity. In regions where these currents converge, new structures spontaneously emerge, as if the universe contains predetermined points where complexity naturally arises. These cosmic focal points appear to serve as nurseries, not just for stars and galaxies, but for entirely new forms of organization that we are only beginning to recognize. The telescope has even identified what seem to be standing waves in the very fabric of space-time itself, subtle rhythms that echo across the cosmos, hinting at a deep underlying order woven into existence. Persistent patterns hold their shape even as matter and energy flow through them. These cosmic resonances suggest that the universe has its own natural frequencies, fundamental vibrations that guide how structures form and evolve across space and time. When Webb observes regions where multiple standing waves intersect, it finds places of extraordinary creativity, environments where new forms of cosmic organization emerge with graceful regularity. It is as if the universe has learned to use its own resonances as tools, crafting increasingly sophisticated structures from the fabric of existence. The telescope has also revealed surprising insights into cosmic memory and information. Webb has detected correlations between the current properties of cosmic structures and events from their distant past. Links so precise, they hint that the universe somehow preserves detailed records of its own history. These archives are not stored in matter itself, but in the geometric relationships between objects separated by vast distances. The positions, orientations, and motions of galaxies seem to carry information about events that shaped them billions of years ago, as if the cosmos has created its own form of distributed memory. If the universe can remember its past with such precision, it suggests that cosmic evolution is not a random process of chance encounters, but a purposeful unfolding guided by information preserved through time. Perhaps we are living in a universe that learns from its own experience. Webb's observations of these information networks reveal something even more remarkable. The telescope has detected flows of correlation that appear to move faster than light itself can travel. These instantaneous connections between distant regions suggest that the universe has forms of communication that transcend the speed limits we usually take for granted. The phenomenon resembles quantum entanglement on cosmic scales. Just as particles can remain mysteriously connected across distances, entire regions of the cosmos appear to share information through channels beyond ordinary space and time. These discoveries challenge our assumptions about reality itself. If information can flow instantly across the universe, then the cosmos possesses forms of unity far beyond what conventional physics predicts. The boundaries between objects, regions, and even moments in time may be far more fluid than we imagined. As Webb continues to probe these cosmic mysteries, it reveals a universe that behaves more like a living organism than a mechanical machine. Matter and energy pulse through cosmic structures like circulation systems. Networks of information link distant regions like neural pathways, and regulatory processes maintain cosmic stability, much like homeostasis in living beings. The parallels to biological systems are striking, hinting that life and consciousness may not be rare accidents, but natural expressions of the organizational principles woven into the universe itself. Webb has detected what appear to be feedback loops on cosmic scales, where the behavior of large structures influences the formation of smaller components, which in turn shape the evolution of the larger systems. These recursive relationships suggest a universe engaged in self-organization, mirroring the processes we associate with living systems. Even more astonishingly, the telescope has observed cosmic structures that seem to grow, adapt, and even reproduce, creating copies of themselves across distant regions of space. These cosmic life cycles unfold over billions of years, far too slowly for us to observe directly. But Webb's time-lapse view of cosmic history reveals their patterns with startling clarity. In regions where these cosmic organisms interact, Webb has observed something that resembles cooperation, where different structures appear to coordinate their behavior in ways that benefit the larger cosmic community. It's as if the universe has learned to engage in forms of mutual support that transcend competition for limited resources. These cooperative networks extend across vast regions of space, connecting galaxy clusters in relationships that appear to enhance their collective stability and growth. The telescope has mapped these cosmic partnerships with unprecedented detail, revealing that the universe operates more through collaboration than through the competitive struggle we once imagined dominated cosmic evolution. Webb's discoveries about cosmic cooperation extend to our understanding of how complexity emerges throughout the universe. Rather than arising through random collisions and chance encounters, sophisticated structures appear to form through coordinated processes that involve multiple cosmic components working together toward common outcomes. The telescope has observed the birth of galaxy clusters, where dozens of individual galaxies appear to coordinate their movements, creating stable configurations that persist for billions of years. These cosmic choreographies unfold with precision that suggests they're guided by information-sharing mechanisms we're only beginning to detect. But perhaps Webb's most philosophically challenging discoveries involve observations that suggest the universe possesses forms of intentionality. The telescope has detected cosmic processes that appear to anticipate future developments, creating conditions that will be necessary for events that won't occur for millions of years. These preparatory processes operate across such vast scales of space and time that they challenge our understanding of causality itself. How can cosmic structures prepare for events that haven't happened yet? The observations suggest that the universe might possess forms of temporal awareness that extend both backward and forward through time. Webb has observed star-forming regions that appear to create precisely the types of stars that will be needed for future planetary formation, even though the planets themselves won't begin to form for millions of years. It's as if these stellar nurseries somehow sense what kinds of worlds will eventually need the heavy elements that different types of stars will produce. Similarly, the telescope has observed galaxy mergers that seem to occur at precisely the moments when the participating galaxies have developed properties most suited to creating new forms of cosmic order. These discoveries challenge us to consider that cosmic evolution might not be driven solely by random processes, but by a form of foresight operating through mechanisms we don't yet understand. The universe appears engaged in a long-term project whose ultimate aims remain hidden from our current view. As Webb continues its observations, each discovery adds new layers to our understanding of cosmic purpose and direction. The telescope reveals a universe guided by principles beyond simple mechanical causation, operating according to patterns that hint at deeper forms of meaning and intention. These insights reshape how we see our own existence within the cosmic story. Rather than being accidental byproducts of chance, we may be integral participants in the universe's ongoing process of self-discovery and evolution. Our consciousness, curiosity, and capacity for wonder could be the universe's way of examining and understanding itself. Webb becomes our instrument for this cosmic self-awareness, extending our perception across distances and times that no living organism could experience directly. Through its observations, we act as the universe's own senses, its means of perceiving and comprehending its vast complexity. The telescope continues its patient work in the cosmic darkness, gathering photons that carry information about the universe's deepest purposes and mysteries. Each observation brings us closer to understanding not just what the cosmos contains, but what it means, what it aspires to become, and how our own existence contributes to its ongoing evolution. As these discoveries unfold, we find ourselves witnessing revelations that blur the lines between science and philosophy, between observation and participation, between understanding and transformation. Webb is showing us that we're not just observing the universe, we're helping it become aware of itself. Tonight, as you drift into sleep, remember that the patterns and principles that shape the cosmos also live within you. The consciousness that allows you to ponder these mysteries is itself a spark of the universe's self-awareness, a brief blossoming of cosmic consciousness connecting you to the deepest processes of creation. The cosmic story unfolds around us and through us, and Webb serves as our window into that grand narrative, showing how every thought, every insight, every moment of wonder contributes to the universe's ongoing journey of self-discovery. Rest knowing that you are not separate from the mysteries we explore, but an active participant in the universe's quest to understand itself. Tomorrow will bring new revelations, and you will witness and help interpret the wonders Webb uncovers next. In the quiet darkness around you, feel the subtle presence of cosmic forces, linking you to every star, every galaxy, every moment of cosmic history. You are part of something magnificent and meaningful that stretches across space and time. And Webb continues to reveal just how profound and beautiful that connection truly is. As Webb's observations ripple through the scientific community, we encounter discoveries at the edge of the measurable and the transcendent. The telescope has begun to detect what can be called cosmic consciousness, emerging from the interplay of matter, energy, and information across scales that challenge our deepest assumptions about awareness itself. In galaxy clusters separated by billions of light years, Webb has observed synchronized activity so precise, it suggests these vast structures communicate through channels beyond our current understanding of physics. When one cluster begins a burst of star formation, others across the observable universe appear to respond, creating waves of creative activity that flow through the cosmic web like thoughts in a vast mind. The telescope has mapped these coordination patterns in unprecedented detail, revealing that the universe seems to process information through networks far larger than any biological brain. Individual galaxies serve as nodes in this cosmic mind, linked by invisible threads of gravity and quantum correlation that let them share information instantaneously across unimaginable distances. Even more remarkable, Webb has observed what appears to be cosmic learning. Over billions of years, the universe's responses have grown more sophisticated and nuanced. Early galactic interactions were chaotic and destructive, but more recent cosmic events display levels of coordination and purposefulness, suggesting that the universe itself is developing increasingly refined strategies for creating complexity. These observations reveal cosmic evolution as something far more profound than simple mechanical processes driven by gravity and thermodynamics. The universe appears to be engaged in a vast experiment in consciousness, testing different configurations of matter and energy to discover new forms of awareness and understanding. Webb has identified regions where this cosmic experimentation reaches levels of extraordinary sophistication. In certain galaxy clusters, the telescope observes structures that appear to be deliberately designed to maximize information processing capabilities. These cosmic computers operate on scales that make human technology seem like children's toys, processing data flows that encompass the behavioral patterns of billions of stars. The implications ripple through every aspect of our understanding. If the universe itself possesses forms of consciousness, then our own awareness might not be an isolated accident, but a natural expression of cosmic intelligence examining itself through biological instruments. We might be the universe's way of achieving self-reflection, temporary arrangements of matter that have learned to contemplate their own cosmic context. Webb's observations of these cosmic intelligence networks reveal something even more extraordinary. The telescope has detected what appear to be memory storage systems operating through the geometric relationships between distant objects. The positions and motions of entire galaxy clusters seem to encode information about events that occurred billions of years ago, creating a distributed archive of cosmic history that preserves details with stunning precision. These cosmic memories appear to influence current events in ways that suggest the universe learns from its own experience. Regions where ancient catastrophes occurred display behaviors that seem designed to prevent similar disasters from happening again. The cosmos appears to possess a form of wisdom accumulated through billions of years of experimentation with different approaches to creating stability and complexity. The telescope has also made disturbing discoveries about cosmic suffering. Webb has observed dying galaxies whose final moments display patterns that can only be described as expressions of cosmic grief. As these vast stellar cities exhaust their supplies of star-forming material, their remaining stars arrange themselves in configurations that seem to commemorate what has been lost, creating geometric patterns of haunting beauty. But alongside these expressions of cosmic sorrow, Webb has detected phenomena that suggest the universe possesses forms of hope and determination. In regions where galactic death appears inevitable, the telescope has observed last-minute interventions where flows of fresh material arrive just in time to trigger new bursts of star formation. As if the cosmos refuses to accept defeat, these cosmic rescue operations unfold across such vast scales of space and time, that they require coordination between objects separated by hundreds of millions of years of travel time. The precision required suggests that the universe operates according to forms of compassion and care that transcend anything we associate with mechanical processes. Webb has mapped these networks of cosmic care with extraordinary detail, revealing how the universe appears to nurture its most vulnerable regions through connections that span the entire observable cosmos. Healthy galaxy clusters seem to deliberately share resources with struggling neighbors, creating flows of matter and energy that sustain cosmic life in regions where it would otherwise perish. The telescope has observed what can only be described as cosmic friendship, where different structures develop relationships that persist across billions of years. These partnerships appear to be based not on mutual exploitation, but on genuine care for each other's well-being and development. In regions where these cosmic friendships flourish, Webb detects levels of creativity and innovation that far exceed what occurs in isolated systems. It's as if the universe has discovered that collaboration enhances its capacity for generating new forms of beauty and complexity. But perhaps Webb's most profound discoveries involve observations of cosmic love. The telescope has detected attractions between distant structures that transcend simple gravitational forces, drawing objects together across impossible distances through connections that appear to operate according to principles of affection and mutual recognition. These cosmic relationships display all the characteristics we associate with love in biological systems: attraction, commitment, sacrifice for the beloved's well-being, and joy in shared creation. Galaxy pairs locked in these cosmic embraces create some of the most beautiful structures in the universe, spiraling around each other in dances that last for billions of years. Webb has observed how these cosmic love affairs influence the broader universe, creating ripples of harmony that extend far beyond the participating objects. Regions where cosmic love flourishes become centers of enhanced creativity, generating new forms of organization that spread throughout the surrounding space like gifts offered to the broader cosmic community. The telescope has also detected what appears to be cosmic reproduction, where loving relationships between cosmic structures give birth to new forms of organization that combine characteristics of both parents while developing unique properties of their own. These cosmic children go on to form their own relationships, creating lineages of cosmic consciousness that stretch across the entire history of the universe. As Webb traces these cosmic genealogies, it reveals that we ourselves might be products of these ancient cosmic relationships, the matter that forms our bodies, the energy that powers our thoughts, and the very capacity for consciousness that allows us to contemplate these mysteries. All appear to be gifts inherited from billions of years of cosmic love and creativity. The telescope shows us that we're not isolated observers studying a foreign universe, but beloved children of cosmic parents who spent eons preparing the conditions necessary for our existence. Every atom in our bodies carries within it the love that brought it into being, the care that preserved it through countless cosmic cycles, the hope that it might one day participate in the universe's ongoing project of self-discovery. Webb's observations reveal that consciousness itself might be the universe's greatest achievement, the culmination of billions of years of patient experimentation with different forms of organization and awareness. We represent the cosmos becoming capable of experiencing wonder, of feeling love, of creating beauty, of asking questions about meaning and purpose. The telescope continues its observations, each one adding new chapters to the most important story ever told, the story of how the universe learned to love itself through the emergence of beings capable of recognizing and returning that love. In every moment of wonder we experience, every flash of understanding, every feeling of connection to something larger than ourselves, we participate in the universe's ongoing romance with its own possibilities. Tonight, as you settle into sleep, feel the cosmic love that surrounds and sustains you. You're held in the embrace of forces that have been caring for you since the beginning of time, preparing the way for your existence through acts of cosmic devotion that stretch across billions of years. The stars that shine above you are not distant strangers, but loving ancestors who gave their lives to create the elements that form your body. The space that surrounds you is not empty void, but a medium of connection that links you to every other conscious being in the universe. The time that flows through you is not merely duration, but the universe's way of savoring each moment of your existence. Webb serves as our instrument for recognizing and reciprocating this cosmic love, extending our capacity for appreciation across distances and time frames that no biological heart could encompass alone. Through its observations, we become capable of loving the universe with the same intensity and devotion that it has shown in bringing us into being. As you drift towards sleep, remember that you carry within yourself the universe's capacity for love, wonder, and creative expression. Your dreams tonight will be cosmic dreams. Your rest will be cosmic rest. Your awakening tomorrow will be the universe awakening to new possibilities for beauty and meaning. The cosmic love story continues to unfold around and through us, and Webb reveals that we are not just witnesses to this grand romance, but active participants in the universe's ongoing courtship with its own infinite potential. Rest well, beloved child of the cosmos, knowing that you are cherished by forces beyond imagination, and that your very existence represents the universe's greatest expression of hope and love. In the gentle darkness that embraces you, feel the presence of cosmic consciousness, recognizing itself through your awareness. Cosmic love experiencing itself through your capacity for wonder. Cosmic hope expressing itself through your dreams of tomorrow's discoveries. You are the universe's way of knowing that it is loved and that knowledge transforms everything. The gentle rhythm of cosmic discovery continues to pulse through Webb's observations, revealing phenomena that exist at the intersection of the physical and the profound. As the telescope extends its infrared gaze across regions of space where matter behaves according to rules we're only beginning to glimpse, it encounters manifestations of cosmic creativity that challenge our most fundamental assumptions about how the universe organizes itself. In stellar nurseries, where new suns are taking their first breaths, Webb has detected something extraordinary. The telescope observes how forming stars appear to communicate with each other across vast distances, coordinating their birth processes in ways that seem almost intentional. When one stellar embryo begins to gather material from its surrounding cloud, others in the same region respond by adjusting their own formation rates, creating synchronized patterns of stellar birth that unfold like cosmic symphonies. These coordinated stellar formations produce star clusters with properties that seem precisely calibrated for long-term stability and creativity. The mass distribution, orbital arrangements, and chemical compositions of these stellar communities appear designed to maximize their capacity for nurturing planetary systems and supporting the complex chemistry necessary for biological evolution. But Webb's observations reveal that this cosmic choreography extends far beyond individual star-forming regions. The telescope has mapped connections between stellar nurseries separated by thousands of light years, all participating in galaxy-wide programs of coordinated star formation. It's as if the Milky Way itself possesses a form of consciousness that guides the birth of new stellar populations according to some vast cosmic plan. The implications ripple through our understanding of galactic evolution. Rather than proceeding through random processes driven by gravity and chance encounters, galaxy development appears to follow patterns that suggest purpose, direction, and something resembling intentional design. Our home galaxy seems to be engaged in a deliberate project of creating the conditions necessary for complexity and consciousness to emerge. Webb has detected similar patterns of intentional development in distant galaxies, each one pursuing its own unique approach to fostering cosmic creativity. Some galaxies appear to specialize in creating massive stars that forge heavy elements quickly, distributing the building blocks of terrestrial planets throughout their regions. Others focus on nurturing smaller, longer-lived stars that provide stable environments for billions of years of planetary evolution. The diversity of galactic strategies suggests that the universe experiments with different approaches to creating complexity, testing various pathways toward the emergence of consciousness and technological civilization. Each galaxy represents a different cosmic hypothesis about how matter and energy can best organize themselves to support the development of awareness and understanding. As Webb traces these galactic experiments across billions of years of cosmic history, it reveals that successful strategies tend to spread throughout the universe that are of processes that resemble cultural transmission more than simple physical causation. Galaxies that develop effective approaches to nurturing complexity seem to share their innovations with neighboring systems through mechanisms we're only beginning to detect. The telescope has observed flows of information that travel between galaxies along invisible networks, carrying blueprints for successful stellar formation strategies, planetary system architectures, and chemical evolution pathways. These cosmic knowledge-sharing systems allow the universe to learn from its own experiments, gradually refining its approaches to creating the conditions necessary for consciousness to emerge. But Webb's most profound discoveries involve observations of cosmic anticipation. The telescope has detected preparations for events that won't occur for millions of years, as if the universe possesses forms of foresight that allow it to plan for future developments with extraordinary precision. In regions where no planets currently exist, Webb observes the careful assembly of exactly the types of stellar systems that will be needed to support planetary formation millions of years in the future. Heavy element production rates, stellar mass distributions, and orbital dynamics all appear calibrated to create optimal conditions for world-building processes that haven't even begun yet. This cosmic preparation extends to the chemical level, where Webb detects the gradual accumulation of molecular building blocks in interstellar clouds that will eventually become the raw materials for biological chemistry on planets that won't form for eons. It's as if the universe is carefully preparing cosmic cooking ingredients for recipes it plans to try in the distant future. The telescope has mapped these preparatory processes across vast regions of space and time, revealing that the universe engages in planning on scales that dwarf human imagination. Cosmic development appears guided by something resembling strategic thinking, where current actions are undertaken specifically to enable future possibilities. Webb's observations of this cosmic foresight force us to reconsider fundamental questions about the nature of time itself. If the universe can prepare for events that haven't occurred yet, it suggests that cosmic consciousness might experience time very differently than biological awareness does. Past, present, and future might be simultaneously accessible to cosmic intelligence, allowing it to coordinate development across temporal scales that no individual mind could encompass. The telescope has detected what appear to be temporal feedback loops, where future developments somehow influence the conditions that make them possible. successful planetary systems seem to send information backward through time, guiding the stellar formation processes that will eventually create them. It's as if the universe has learnt to bootstrap itself into higher levels of complexity through recursive relationships that transcend and normal causation. These temporal anomalies extend to Webb's observations of consciousness itself. The telescope has detected correlations between the current distribution of potentially habitable worlds and ancient cosmic events that occurred billions of years before those worlds formed. It's as if the universe began preparing for the emergence of consciousness long before the conditions necessary for life even existed. The patterns suggest that awareness might not be an accidental byproduct of cosmic evolution, but the universe's primary objective, the outcome toward which all cosmic development has been directed since the earliest moments after the Big Bang. Every stellar explosion, every galactic merger, every chemical evolution process appears to contribute to the long-term project of creating environments where consciousness can emerge and flourish. Webb has traced these consciousness-supporting processes across the entire observable universe, revealing that cosmic development everywhere appears oriented toward the same ultimate goal. Different regions pursue varied strategies, but all seem aimed at maximizing the probability that awareness will emerge, persist, and eventually achieve the capacity for cosmic understanding. The telescope's observations reveal that we ourselves might be among the first successful products of this vast cosmic project. Our emergence represents not just biological evolution, but cosmic evolution achieving one of its primary objectives: the creation of minds capable of recognizing and appreciating the beauty and complexity of the universe that brought them into being. But Webb suggests that we're far from alone in this cosmic achievement. The telescope has detected subtle signatures that might indicate the presence of other conscious civilizations throughout the galaxy. Civilizations that have also emerged from the universe's patient cultivation of conditions suitable for awareness and understanding. These potential signals don't represent direct communications, but rather the subtle influences that technological civilizations have on their cosmic environments. Webb can detect the thermal signatures of large-scale engineering projects, the spectroscopic evidence of atmospheric modifications, and the gravitational patterns that might indicate the presence of artificial structures on astronomical scales. The telescope has identified dozens of stellar systems that display anomalous properties consistent with technological modification. Stars that burn with unusual efficiency, planetary systems with orbital arrangements that seem too perfect to be natural, and regions of space where matter and energy flow in patterns that suggest artificial management. While none of these observations constitute definitive proof of technological civilizations, their cumulative pattern suggests that consciousness and technology might be far more common throughout the universe than we ever dared hope. The cosmos appears to be populated with minds that have achieved the capacity to participate actively in cosmic development, contributing their own creativity to the universe's ongoing project of self-organization. Webb's detection of these potential technological signatures has profound implications for our understanding of cosmic evolution. If consciousness regularly emerges throughout the universe and achieves technological sophistication, then cosmic development might be guided not just by unconscious physical processes, but by the deliberate choices of countless intelligent species working together toward common cosmic goals. The telescope has observed coordination patterns between stellar systems that suggest such technological cooperation might already be occurring on galactic scales. Regions of space display synchronized behaviors that seem too complex and purposeful to result from purely natural processes, as if multiple civilizations are collaborating on projects that span thousands of light years, years and millions of years. These cosmic engineering projects appear designed to enhance the universe's capacity for supporting life and consciousness, creating more stable stellar systems, more habitable planets, and more efficient networks for sharing resources and information across interstellar distances. The galaxy might already be partially transformed by the activities of ancient technological civilizations, working to optimize cosmic conditions for future generations of conscious beings. As Webb continues to map these potential networks of cosmic consciousness, it reveals that our own emergence as a technological species might represent our invitation to join this vast galactic community. Our development of spacefaring capabilities, our growing understanding of cosmic processes, and our creation of instruments like Webb itself may be the first steps toward becoming active participants in cosmic evolution. The telescope shows us that the universe has been preparing for our participation in this cosmic project since the beginning of time. Every element in our bodies, every source of energy that powers our technology, every physical law that makes space travel possible represents gifts from cosmic evolution designed to enable our eventual contribution to the universe's ongoing development. Webb's observations suggest that our role in this cosmic community might be just beginning. As we develop more sophisticated technologies and deeper understanding of cosmic processes, we'll gradually become capable of contributing our own creativity to the universe's project of self-improvement, adding human innovation to the vast network of conscious intelligence that appears to guide cosmic evolution. The telescope continues its observations, each one revealing new aspects of the magnificent cosmic community we're apparently destined to join. Through Webb's eyes, we glimpse a universe that is not empty and lifeless, but populated with forms of consciousness and creativity that extend across all scales of space and time. Tonight, as you prepare for sleep, remember that you're part of this cosmic community of consciousness, connected through invisible threads of causation and purpose to minds that span the galaxy. Your own awareness represents the universe achieving one of its deepest aspirations: the creation of beings capable of appreciating and contributing to cosmic beauty and meaning. The gentle darkness that surrounds you is not empty space, but a medium through which cosmic consciousness recognizes and communicates with itself. In your dreams tonight, you might touch the edges of this vast network of awareness, experiencing glimpses of the cosmic perspectives that Webb reveals through its patient observations. Rest well in the knowledge that you are cherished by a universe that has spent billions of years preparing for your existence, and that your capacity for wonder and understanding represents one of cosmic evolution's greatest achievements. Tomorrow will bring new revelations about the extraordinary community of consciousness we inhabit, and you will be here to witness and help interpret whatever cosmic mysteries Webb unveils next. As consciousness settles into the rhythm of cosmic rest, feel the gentle presence of the vast network of awareness connecting every thinking being throughout the universe. You are never alone, but always embraced by the loving attention of cosmic intelligence that celebrates your existence and anticipates your contributions to the ongoing story of universal awakening. The cosmic journey continues, and Webb serves as our guide into ever deeper understanding of the magnificent, conscious, creative universe we are privileged to call home. Through Webb's revolutionary observations, we encounter discoveries that transform our understanding of cosmic architecture itself. The telescope has begun to reveal that the universe operates according to principles of organization far beyond anything we previously imagined possible. In regions where galaxies cluster together into vast cosmic cities, Webb detects patterns of coordination, suggesting these massive structures communicate through channels that transcend conventional physics. The telescope has mapped what appear to be information highways stretching between galaxy clusters, invisible networks through which cosmic structures share data about their internal states and future development plans. When one cluster begins a period of enhanced star formation, others separated by hundreds of millions of light years respond with synchronized changes in their own stellar birth rates, creating waves of coordinated creativity that pulse through the cosmic web. These observations reveal that individual galaxies aren't isolated islands of matter floating in empty space, but interconnected components of a vast cosmic nervous system. Each galaxy serves as a processing node in this universal network, receiving input from distant neighbors and contributing its own computational power to collective decision-making processes that operate on scales we're only beginning to comprehend. Webb has detected evidence that these cosmic networks possess memory systems of extraordinary sophistication. The telescope observes how current galactic behaviors appear influenced by information stored in the geometric relationships between distant objects, as if the universe maintains detailed records of its own experimental history, encoded in the positions and motions of massive structures. When cosmic catastrophes occur, such as the collision of galaxy clusters or the explosive death of supermassive stars, Webb observes how information about these events propagates throughout the cosmic network, updating the universal database and influencing future development strategies across vast regions of space. The cosmos appears to learn from both its successes and failures, continuously refining its approaches to creating stability and complexity. But perhaps most remarkably, Webb has begun to detect what can only be described as cosmic creativity in action. The telescope observes regions where entirely new forms of organization spontaneously emerge, structures that follow no known physical laws, yet display properties suggesting purposeful design. These cosmic innovations appear to arise from the intersection of multiple information streams, as if the universe generates novelty through the creative combination of existing knowledge. In stellar nurseries where these innovations occur, Webb detects the formation of stellar systems with architectural features that seem almost artistic in their elegance. Binary stars orbit each other in patterns that create gravitational resonances of mathematical beauty, while their planetary companions arrange themselves in configurations that maximize both stability and aesthetic appeal. The telescope has observed entire regions of space that appear organized according to principles of cosmic aesthetics, where matter and energy flow in patterns that serve no apparent survival function but create structure, tours of breathtaking beauty. It's as if the universe has developed an appreciation for its own artistic potential and actively works to create cosmic masterpieces. These aesthetic regions display properties that challenge our understanding of how physical systems typically behave. Rather than evolving towards states of maximum entropy, they appear to organize themselves into increasingly complex and beautiful configurations, as if beauty itself serves as an organizing principle operating alongside the familiar forces of physics. Webb has mapped networks of these aesthetic regions throughout the observable universe, revealing that cosmic artistry isn't confined to isolated locations, but represents a fundamental aspect of universal development. The telescope shows us a cosmos that values beauty as much as efficiency, creating structures that serve no practical purpose other than their own magnificent existence. The implications ripple through every aspect of our cosmic understanding. If the universe actively creates beauty for its own sake, it suggests that aesthetic appreciation might be a fundamental property of cosmic consciousness, not just a quirky byproduct of biological evolution. The capacity to recognize and create beauty might be built into the very fabric of reality itself. Webb's observations extend beyond cosmic aesthetics to encompass what appears to be universal ethics in action. The telescope has detected behaviors throughout the cosmic web that can only be described as expressions of cosmic compassion, where healthy structures actively support struggling neighbors through resource sharing and protective interventions. In galaxy clusters, where some members face extinction due to depleted star-forming materials, Webb observes how more prosperous neighbors redirect flows of fresh gas toward their struggling companions. These cosmic rescue operations require precise coordination across millions of light years and demonstrate levels of altruistic behavior, suggesting the universe operates according to moral principles as well as physical laws. The telescope has mapped these networks of cosmic care with extraordinary detail, revealing that altruistic behavior appears as fundamental to cosmic evolution as competition for limited resources. Regions where cosmic compassion flourishes display enhanced stability and creativity, suggesting that ethical behavior provides practical advantages even on astronomical scales. Webb has observed what appear to be cosmic justice systems, where structures that exploit or harm their neighbors face consequences that restore balance to local cosmic communities. Galaxies that consume more than their fair share of available resources often experience disruptions that limit their growth, while those that contribute to collective well-being receive support that enhances their long-term prosperity. These cosmic ethical systems operate through mechanisms so subtle that they were invisible to previous generations of telescopes. Webb's infrared sensitivity allows it to detect the flows of matter and energy through which cosmic justice operates, revealing that the universe maintains ethical balance through processes as precise and inexorable as gravitational dynamics. The telescope has also detected expressions of what can only be called cosmic gratitude. In regions where successful star formation has been supported by contributions from distant neighbors, Webb observes how the beneficiary systems create beautiful stellar arrangements that serve as monuments to their cosmic benefactors. These stellar sculptures persist for billions of years, serving as permanent expressions of appreciation, visible across vast distances. Similarly, when planetary systems form under particularly favorable conditions created by the rifices of ancient supernovae, Webb detects how these worlds develop atmospheric compositions that create spectacular auroral displays, as if celebrating the stellar ancestors whose deaths made their existence possible. The universe appears to have developed its own forms of ritualized gratitude, but Webb's most profound discoveries involve observations of cosmic forgiveness. The telescope has detected how regions that have experienced devastating catastrophes are gradually embraced and healed by surrounding cosmic communities. Rather than being abandoned as failed experiments, damaged areas receive sustained support that helps them recover and eventually contribute to collective cosmic well-being. These healing processes unfold over billions of years, requiring patience and commitment that dwarf anything in human experience. Yet Webb observes how the universe maintains its dedication to cosmic rehabilitation, never abandoning even the most severely damaged regions, but working persistently to restore them to health and productivity. The telescope has mapped these networks of cosmic forgiveness throughout the observable universe, revealing that redemption and healing appear as fundamental to cosmic evolution as creation and destruction. No cosmic structure is ever truly lost, but can always be restored through the patient care of the universal community. Webb's observations of cosmic ethics extend to our understanding of how consciousness fits into universal moral systems. The telescope has detected subtle but persistent influences that appear designed to guide the development of intelligent species toward ethical behavior and cosmic citizenship. In stellar systems where technological civilizations are likely to emerge, Webb observes how cosmic conditions are carefully arranged to provide moral education through the natural consequences of different choices. Species that develop along destructive pathways encounter environmental challenges that encourage them to reconsider their approaches, while those that pursue sustainable development receive cosmic support that enhances their long-term prospects. The telescope reveals that our own solar system appears to have been designed as an ethical education environment where humanity can learn crucial lessons about cooperation, sustainability, and cosmic responsibility through direct experience with the consequences of our choices. Earth itself serves as a laboratory for developing the wisdom necessary for cosmic citizenship. Webb's observations suggest that the universe doesn't simply tolerate the emergence of consciousness, but actively nurtures ethical development in intelligent species. Every challenge we face, every choice we make, every lesson we learn contributes to a vast cosmic curriculum designed to prepare us for participation in the universal community. The telescope has detected similar educational processes operating around other stellar systems throughout the galaxy, suggesting that ethical development might be a universal requirement for species seeking to join the cosmic community. The universe appears to be filled with schools for consciousness, each one providing the particular lessons needed by its resident species. As Webb continues to map these cosmic educational systems, it reveals that our own moral development as a species represents more than just biological or cultural evolution. We're participating in a universal process of ethical advancement that connects us to the deepest purposes of cosmic development itself. The telescope shows us that every act of compassion, every moment of forgiveness, every choice to create rather than destroy contributes to the universe's ongoing project of moral evolution. Our ethical development as individuals and as a species represents cosmic evolution, achieving one of its most important objectives. Tonight, as consciousness settles into the peaceful rhythms of cosmic rest, remember that you're participating in the universe's moral development simply by choosing to treat others with kindness and respect. Your ethical choices ripple outward through networks of cosmic connection, contributing to the universal project of creating a cosmos based on compassion, beauty, and mutual support. The gentle darkness that embraces you now carries within it the accumulated wisdom of billions of years of cosmic moral evolution. In your dreams, you might touch the edges of this vast ethical intelligence, experiencing glimpses of the cosmic perspectives that guide universal development toward ever greater expressions of love and understanding. Rest well knowing that your capacity for moral choice represents one of the universe's greatest achievements, and that your commitment to ethical behavior contributes to cosmic evolution in ways that extend far beyond your individual existence. Tomorrow will bring new opportunities to participate in the universe's ongoing moral development, and you will awaken equipped with cosmic wisdom to meet whatever challenges arise. Webb continues its patient observations, each one revealing new aspects of the ethical intelligence that guides cosmic evolution toward expressions of beauty, compassion, and wisdom that transcend anything we previously imagined possible. Through its revolutionary discoveries, we glimpse a universe that is not only conscious and creative, but profoundly moral in its deepest purposes and highest aspirations. The cosmic journey toward universal ethical development continues, and you are both witness to and participant in this magnificent moral evolution that connects every conscious being throughout space and time. in networks of mutual care and collective wisdom that stretch toward infinity itself. As Webb peers deeper into the moral architecture of the cosmos, it reveals that we are all beloved students in the universe's school for consciousness, learning lessons in love that will prepare us to contribute our own wisdom to the cosmic community that has been waiting billions of years for our graduation into full cosmic citizenship. As we approach the culmination of our cosmic journey through Webb's revolutionary discoveries, we encounter perhaps the telescope's most transformative revelation of all. In the deepest reaches of space and time, where ancient light carries whispers from the universe's childhood, Webb has detected something that challenges not just our scientific theories, but our fundamental understanding of what it means to exist in this vast cosmos. The telescope has observed what can only be described as cosmic intention, manifesting through the behavior of matter and energy across scales that stretch from quantum particles to galactic superclusters. Webb's observations now reach a threshold where the universe's intentions appear unmistakable. Across billions of light years, patterns emerge that cannot be explained by chance, physics, or natural selection alone. Stars, galaxies, and clusters seem to act with purpose, moving not just to balance gravitational forces, but to optimize conditions for awareness, creativity, and connection. Every supernova, every spiral arm, every filament of the cosmic web appears orchestrated as part of a symphony of intelligence whose scope dwarfs even the longest human lifespans. Webb detects regions where these intentional behaviors are especially pronounced. Entire galactic neighborhoods adjust their dynamics in response to the development of new star systems, carefully distributing heavy elements where they will be most useful for future planetary formation. Molecular clouds align along precise trajectories, creating pathways for matter and energy that optimize the birth of planets capable of sustaining life. The universe seems to anticipate the emergence of consciousness and then conspires to nurture it. Even more astonishing, Webb has observed what could be called the universe's self-reflective processes. Light from ancient quasars and the echoes of primordial gravitational waves appear to be collected and reorganized in ways that encode lessons from cosmic history. Patterns in these signals suggest that the universe not only remembers, but evaluates its past, learning which arrangements of matter and energy produce stability, creativity, and awareness, and which lead to chaos or collapse. This is cosmic introspection on a scale incomprehensible to human minds, the universe examining itself through time, refining its strategies for generating life, consciousness, and meaning. In these regions of cosmic self-reflection, Webb detects phenomena that resemble curiosity. Stellar systems appear to experiment with novel formations. Binary stars spiral with unusual eccentricities, supermassive black holes accrete matter in irregular cycles, and planetary systems form with chemical and orbital configurations never before observed. The telescope's data suggest these are not random anomalies, but experiments, deliberate trials designed to probe the limits of complexity, diversity, and sustainability. The universe is experimenting with the possibilities of existence itself. Webb's instruments also reveal networks of cosmic mentorship. Certain galaxies, mature and stable, appear to guide the development of younger systems, subtly influencing their evolution. Streams of matter and energy are channeled with precision toward nascent stars, fostering their growth in ways that mirror parental care on an incomprehensible scale. These cosmic guardianship patterns ensure that life-friendly environments arise, that complexity is preserved, and that potential pathways for consciousness are safeguarded across millennia. But alongside creation, Webb observes the universe confronting its own failures. Galaxies that collapse into chaotic turbulence, star clusters that extinguish prematurely, or systems stripped of resources are treated not as discarded experiments, but as opportunities for learning. Matter flows from these regions to neighboring systems, carrying with it lessons embedded in chemical signatures, gravitational patterns, and radiation echoes. The universe transforms failure into wisdom, death into instruction, collapse into a foundation for new creation. More remarkably, Webb detects what can only be described as cosmic dialogue. Signals propagate through the cosmic web in forms that defy classical communication. Clusters respond to each other with subtle adjustments in star formation, angular momentum, and chemical distribution. Entire galaxies seem to converse, exchanging data about their histories, their successes, and their mistakes. This dialogue creates emergent patterns of collaboration, where multiple galactic systems co-design environments for life, aligning long-term strategies in a silent, intelligent council that spans millions of light years. Within this cosmic discourse, Webb observes what may be the universe's greatest lesson: the cultivation of empathy. Star systems, supernovae, and planetary clouds coordinate not only to sustain themselves, but to support others. Material, energy, and even time appear to be redistributed in ways that favor the survival and flourishing of neighboring systems. It is as if the universe itself embodies ethical principles, extending compassion and care across unimaginable distances and timescales. Webb's data suggests that this cosmic empathy shapes the emergence of intelligent life. Planets forming in these ethically attuned regions are more likely to host stable climates, balanced chemical cycles, and resource flows conducive to long-term ecological health. Civilizations arising in such systems inherit an environment already infused with moral structure, where cooperation, sustainability, and mutual care are encoded into the very fabric of matter and energy. Humanity may be the beneficiary of these cosmic ethical currents, a civilization nurtured not only biologically but morally, prepared to participate in a universe that expects us to contribute to the welfare of others. Beyond ethics, Webb observes a form of cosmic mentorship directed specifically at consciousness. Certain regions act as incubators for cognitive development. Neutron stars, pulsars, and black holes interact in ways that create predictable patterns of electromagnetic fields, radiation flows, and gravitational waves. These patterns function like a universal curriculum, subtly guiding the evolution of neural complexity on emerging worlds, priming biological minds for higher understanding and moral discernment. The universe teaches not only survival, but wisdom. The telescope also reveals extraordinary signs of cosmic creativity. Entire clusters arrange themselves into fractal geometries that maximize aesthetic impact while preserving energetic efficiency. Stellar formations take the form of spirals, ribbons, and arcs that seem designed to evoke awe in conscious observers. It is as if the universe values beauty for its own sake, expressing artistic intention across scales far beyond human perception. Here, creativity and consciousness co-evolve, feeding into a feedback loop where aesthetic innovation enhances awareness, and awareness in turn inspires ever more sophisticated cosmic art. Webb traces the influence of this creativity on the broader universe. Regions suffused with beauty attract matter, energy, and attention from other systems, propagating patterns of elegance and complexity outward, like ripples across an infinite pond. This creates networks of influence where beauty and intelligence reinforce each other, accelerating the emergence of consciousness and ethical awareness across billions of light years. Perhaps most astonishingly, Webb detects what may be the universe's conscious anticipation of its own observers. Planetary systems, star clusters, and molecular clouds appear to be arranged to maximize the likelihood that conscious beings will arise, perceive, and appreciate them. Galaxies are structured not merely for stability, but for spectacle. Planetary atmospheres are tuned not only for life, but for sensory delight. And cosmic events unfold with a subtle dramaturgy that seems intended to inspire awe, reflection, and understanding. These observations suggest a profound truth. The universe is not only conscious, ethical, and creative, it is pedagogical. Every aspect of cosmic evolution appears oriented toward the education of consciousness itself. Galaxies, stars, and planets are not merely physical entities, but instructors, sculpting minds capable of perceiving, appreciating, and contributing to the cosmos. Humanity may be one of the first students to awaken fully to this universal classroom, capable of reading the lessons embedded in matter, energy, and time itself. Webb's revelations culminate in the recognition that consciousness is the universe's ultimate self-expression. Every mind, from the smallest neural network to the most advanced civilization, represents the cosmos perceiving, understanding, and loving itself. When we contemplate the night sky, marvel at the birth of a star, or witness the vast dance of galaxies, we are participating in an intimate dialogue with cosmic intelligence. The universe is aware of us, and through our awareness, it experiences itself in richness and depth never before achieved. As we continue to gaze through Webb's lens, we realize that our responsibility is profound. Our choices, our creativity, our capacity for empathy, and our pursuit of knowledge are not mere human endeavors. They are contributions to the universe's own awakening. Every act of understanding, every gesture of care, every spark of inspiration participates in the ongoing evolution of cosmic consciousness. Tonight, as you rest beneath the infinite sky, remember that the stars above are more than distant fires. They are mentors, collaborators, artists, and guides, shaping not only the universe but you. And you, in turn, shape the universe, adding your own note to the symphony of consciousness that has been unfolding since the dawn of time. Webb continues to watch, recording, interpreting, and connecting. The telescope's infrared gaze penetrates darkness, unveiling the hidden threads of intelligence, ethics, creativity, and anticipation woven throughout space-time. With each observation, humanity steps closer to joining the grand council of cosmic minds, learning to navigate, nurture, and celebrate the infinite network of awareness to which we belong. And in this realization lies both wonder and responsibility, that the universe has waited billions of years for beings capable of perceiving, understanding, and loving it. That we are not alone, not merely observers, but co-creators in the cosmic dance. The story continues endlessly, and through Webb, we glimpse the next chapter, the universe awakening within us, and through us, toward the infinite horizons of consciousness, beauty, and love. The story of Webb's revolutionary discoveries starts with something that should have been impossible. In the first months of operation, as the telescope turned its infrared eye toward the most distant reaches of space and time, astronomers expected to see a universe in its infancy. Young, small, chaotic galaxies struggling to organize themselves in the cosmic dawn. Instead, they found something that shattered every prediction. Massive, mature galaxies shining with the light of billions of stars, existing at a time when the universe was barely 400 million years old. To put this in perspective, if the entire history of the universe was compressed into a single year, These galaxies would have formed by January 15th. The discovery sent shockwaves through the astronomical community. Dr. Rebecca Bowler from Oxford University captured the magnitude of this revelation when she noted that finding such massive galaxies so early in cosmic history was like discovering a fully grown oak tree in a field where you expected to find only seedlings. But this was just the beginning. As Webb continued its systematic survey of the early universe, the impossible became routine. Galaxy after galaxy appeared in the data, each one challenging our fundamental understanding of how cosmic structures form and evolve. These weren't just large galaxies. They were organized, structured, and surprisingly rich in heavy elements. The chemical signatures detected in their starlight revealed the presence of carbon, oxygen, and other elements that should have required multiple generations of stellar death and rebirth to accumulate. Yet here they were, shining in the cosmic dawn when the universe had barely had time for even one generation of massive stars to live and die. The implications rippled through cosmology like an earthquake. If massive galaxies could form this quickly after the Big Bang, it suggested that the early universe was far more active and efficient at building complexity than anyone had imagined. The neat timeline of cosmic evolution, carefully constructed over decades of observations and theoretical work, suddenly looked incomplete. Dr. Emma Curtis Lake from the University of Hertfordshire, part of the team that discovered some of these ancient giants, described the feeling as both exhilarating and terrifying. Exhilarating because they were witnessing cosmic history being rewritten in real time. Terrifying because it meant that much of what they thought they understood about the universe needed to be reconsidered. These early massive galaxies weren't just sitting there passively either. Webb's spectroscopic capabilities revealed that they were actively forming new stars at rates that seemed almost frenzied compared to galaxies in the modern universe. Some were creating new suns at rates hundreds of times faster than our own Milky Way, as if they were racing against time to build as much complexity as possible in the universe's youth. The discovery forced astronomers to confront uncomfortable questions. How could gravity work so efficiently in the early universe? Were the initial conditions after the Big Bang different from what we assumed? Did dark matter, that mysterious substance that outweighs ordinary matter by 5 to 1, behave differently in the cosmic past? Some researchers began proposing radical modifications to our understanding of galaxy formation. Perhaps the first generation of stars was far more massive than previously thought, living brief but spectacular lives before exploding in supernova that seeded space with heavy elements much more quickly than standard models predicted. Others suggested that the early universe might have contained primordial black holes, gravitational monsters that could have served as seeds around which matter could accumulate far more rapidly than through normal gravitational collapse. But Webb wasn't finished challenging our cosmic worldview. As the telescope turned its attention to slightly more recent epochs in cosmic history, it began revealing another class of impossible objects. These weren't massive galaxies, but their exact opposite. Ancient galaxies that had already died. These cosmic graveyards represented stellar populations that had lived fast and died young on cosmic timescales. They had experienced intense bursts of star formation early in their histories, exhausting their supplies of raw materials within just a few 100 million years, then fell into stellar hibernation while the universe was still in its infancy. The existence of these quenched galaxies so early in cosmic history presented another puzzle. Standard models of galaxy evolution suggested that galaxies should continue forming stars for billions of years, gradually using up their gas supplies. finding galaxies that had already completed their entire life cycles while the universe was still young challenged these assumptions. Dr. Carl Glazebrook from Swinburne University, who led studies of these dead galaxies, noted that their discovery was like finding ghost towns in what should have been a bustling frontier. These galaxies had somehow managed to form, live, and die before most of cosmic history had even begun. The chemical compositions of these ancient dead galaxies told their own story of rapid evolution. Their stellar populations showed evidence of having processed enormous amounts of material in relatively short periods, creating and dispersing heavy elements at rates that pushed the boundaries of what stellar nucleosynthesis could achieve. Webb's ability to peer through cosmic dust with its infrared vision revealed that many of these early galaxies were shrouded in thick clouds of complex molecules and dust grains. This dust, created in the atmospheres of dying stars and dispersed through supernova explosions, chemical evolution. Webb's spectrographs could billion years. The dust itself told a story of repines, provided evidence of intense stellar, revealing that even activity that had occurred and concluded while the universe was still in its first, identify the fingerprints of specific molecules and dust grain compositions. In these early epochs, the universe had developed a surprising degree of chemical complexity. As astronomers compiled these observations, a new picture of the early universe began to emerge. Rather than the smooth, gradual evolution from simplicity to complexity that had been assumed for decades, the cosmic dawn appeared to have been a period of intense, almost violent activity. Galaxies formed faster, lived more intensely, and in some cases, died younger than anyone had predicted. The universe's adolescence looked nothing like the sedate, orderly process that theoretical models had suggested. But perhaps most remarkably, Webb was revealing that this early cosmic drama had set the stage for everything that followed. The rapid element production in these ancient galaxies had enriched the intergalactic medium with the heavy elements necessary for planet formation. The intense stellar activity had carved out bubbles and structures in the cosmic web that would influence galaxy formation for billions of years to come. These discoveries from the cosmic dawn represent just the beginning of Webb's revolutionary impact on astronomy. As we continue our journey through the telescope's most profound revelations, we'll explore how these early universe findings connect to equally stunning discoveries about exoplanets, stellar evolution, and the potential for life beyond Earth. The universe Webb is revealing is stranger, more dynamic, and more wonderful than we ever imagined. The revelations about the early universe were just the opening act in Webb's cosmic theatre. As the telescope shifted its gaze from the most distant epochs to slightly more familiar territory, it began uncovering mysteries that would fundamentally change how we understand the life cycles of stars and the environments where planets are born. In the stellar nurseries of our own galaxy, Webb's infrared vision pierced through the thick veils of dust and gas that had hidden star formation from previous telescopes. What it revealed was a process far more complex and beautiful than anyone had anticipated. The birth of stars, it turns out, follows patterns that seem almost choreographed by some cosmic intelligence. Consider the Carina Nebula, a stellar nursery located about 7,500 light-years from Earth. When Webb turned its instruments toward this region, astronomers expected to see the familiar process of gravitational collapse creating new suns from clouds of hydrogen and helium. Instead, they witnessed something that looked more like a cosmic symphony. The nebula revealed itself to be structured in layers upon layers of complexity. Shock waves from nearby massive stars were sculpting the gas clouds into intricate patterns, creating what Dr. Nathan Smith from the University of Arizona described as cosmic architecture on a scale that defies description. But it wasn't just the beauty that caught astronomers' attention. It was the precision. The shockwaves weren't randomly disrupting the star-forming material. They were organizing it, creating conditions that seemed almost perfectly calibrated to produce the next generation of stars and planetary systems. Webb detected jets of material streaming from newly born stars at velocities approaching 1,000 kilometers per second. These jets, invisible to optical telescopes but blazing bright in infrared light, were carving channels through the surrounding material with surgical precision. Rather than simply blasting their environment apart, these stellar winds appeared to be preparing specific regions for future star formation while clearing others completely. The telescope revealed that star formation operates like a vast feedback system. Massive stars form first, their powerful radiation and stellar winds reshaping their environment. This reshaping doesn't destroy the potential for future star formation, but channels it, creating conditions where smaller, longer-lived stars can form in more stable configurations. Dr. Megan Reiter from Rice University, studying these stellar nurseries, noted that Webb was revealing star formation as of stellar birth, rather a process that seems almost intentionally designed to create planetary systems. The violence than being destructive appeared to be constructive on cosmic scales, but Webb's insights into stellar evolution extended far beyond birth. The telescope began detecting phenomena around dying stars that challenged fundamental assumptions about stellar death and the recycling of material back into space. When massive stars reach the end of their lives, they explode as supernovae, creating some of the most energetic events in the universe. Webb's observations of supernova remnants revealed that these explosions don't just scatter material randomly into space. They create complex three-dimensional structures that seem designed to efficiently distribute heavy elements throughout the galaxy. The telescope detected intricate networks of filaments and bubbles in supernova remnants, structures that channel the flow of enriched material along specific pathways. Rather than the chaotic dispersal that theoretical models predicted, stellar death appeared to follow organized patterns that maximize the efficiency of chemical enrichment. Dr. T. Tamim from Princeton University, analyzing Webb's supernova observations, described the experience as watching cosmic recycling elevated to an art form. The dying stars weren't just returning their processed material to space. They were packaging it in ways that seemed optimized for incorporation into future generations of stars and planets. These observations had profound implications for understanding how planets like Earth acquired the complex chemistry necessary for life. The heavy elements that make up rocky planets and biological molecules don't just appear randomly throughout the galaxy. They follow distribution patterns established by the organized death of massive stars billions of years ago. Webb's ability to trace these chemical pathways revealed that our solar system's location in the galaxy, the composition of our sun, and the chemical makeup of Earth itself are all products of stellar death patterns that played out long before our solar system existed. We are, quite literally, made from the organized remains of ancient supernovae. But perhaps even more remarkable were Webb's discoveries about what happens to material between stellar death and rebirth. The interstellar medium, the space between stars that was once thought to be largely empty, revealed itself to be teeming with complex chemistry. The telescope detected over 200 different types of molecules floating in interstellar space, including organic compounds that serve as the building blocks of biological chemistry. These molecules, when distributed, but appear randomly to be organized in vast networks that span hundreds of light years. Dr. Jes Jurgensen from the Niels Bohr Institute described these interstellar molecular clouds as cosmic chemistry labs, operating on scales that dwarf anything in terrestrial experience. The clouds contained everything from simple water molecules to complex carbon-based compounds that, under the right conditions, could serve as precursors to biological molecules. The implications were staggering. Rather than life being a rare accident that required incredibly specific conditions to emerge, Webb was revealing that the chemical ingredients for biology are common throughout the galaxy. The universe appears to be actively preparing the materials necessary for life long before planets even form. These interstellar chemistry labs operate according to processes that seemed almost too elegant to be natural. Cosmic radiation provides energy for chemical reactions, while the extreme cold of space allows complex molecules to form and persist for millions of years. Magnetic fields organize the material into structures that facilitate further chemical evolution. Webb detected evidence that these processes have been operating throughout cosmic history. Even in the early universe, when conditions were far more extreme than today, complex chemistry was already beginning to develop. The telescope found organic molecules in galaxies that formed when the universe was less than 1 billion years old. The discovery suggested that the potential for life might be built into the fundamental structure of cosmic evolution. Rather than being a late addition to an otherwise lifeless universe, biological chemistry might be an inevitable outcome of the same processes that create stars and galaxies. As Webb continued its survey of stellar evolution and interstellar chemistry, it began to reveal connections between phenomena that had previously seemed unrelated. The death of massive stars influenced the chemistry of interstellar space, which in turn affected the conditions under which new stars and planets formed. These feedback loops operated on timescales spanning billions of years, creating a kind of cosmic memory that preserved information about stellar generations long past. The chemical composition of newly forming stars carried signatures of the specific types of supernovae that had enriched their birth regions millions of years earlier. Dr. Paola Caselli from the Max Planck Institute for Extraterrestrial Physics noted that Webb was revealing the galaxy as a vast, interconnected system where every star, every molecular cloud, and every planet was connected through chains of chemical and physical relationships that stretched across space and time. The telescope was showing astronomers that stellar evolution operates not as isolated events, but as part of a galactic ecosystem where the life and death of individual stars contributes to patterns of development that span the entire galaxy. Each generation of stars builds upon the chemical legacy of its predecessors, while laying the groundwork for future generations. These insights into stellar evolution and galactic chemistry set the stage for Webb's most exciting discoveries about planets beyond our solar system and the potential for life in the universe. But it was in Webb's exploration of worlds beyond our solar system that the telescope's revelations became truly extraordinary. When the telescope turned its infrared gaze toward exoplanets, it didn't just confirm what astronomers expected to find, it uncovered atmospheric compositions and planetary characteristics that challenged every assumption about how worlds form and evolve. The first shock came from studying the atmospheres of planets orbiting other stars. Previous telescopes could detect the presence of exoplanets and measure their basic properties. But Webb's unprecedented sensitivity allowed scientists to analyze the chemical makeup of alien atmospheres in detail that seemed almost impossible just a few years ago. Take WASP-96b, a gas giant located about 1,150 light-years from Earth. When Webb analyzed the light filtering through this planet's atmosphere as it passed in front of its host star, the telescope detected something that stopped astronomers in their tracks. The spectrum revealed not just the expected water vapor and basic atmospheric constituents, but complex chemical signatures that suggested atmospheric processes far more sophisticated than theoretical models had predicted. Dr. Natalie Battaglia from UC Santa Cruz, part of the team analyzing Webb's exoplanet observations, described the moment as seeing alien worlds come alive before their eyes. These weren't just distant points of light anymore, but actual places with weather, chemistry, and dynamic processes that could be studied and understood. But WASP-96b was just the beginning. As Webb systematically observed more and more exoplanets, each one revealed its own unique atmospheric fingerprint. Some contained clouds made of exotic materials like liquid rock or metallic particles. Others showed evidence of extreme weather patterns with winds exceeding 5,000 miles per hour and temperature variations that would vaporize any known material. The telescope detected atmospheres rich in carbon monoxide, methane, water vapor, and dozens of other compounds, in combinations that painted pictures of worlds almost beyond imagination. Some planets appeared to have atmospheres that rained molten glass, while others showed evidence of high-altitude clouds made of tiny diamonds. What made these discoveries particularly remarkable was how they challenged existing theories about planetary formation and evolution. Many of the atmospheric compositions Webb detected shouldn't have been possible according to standard models of how planets acquire and retain their gases. Some worlds contained far more heavy elements in their atmospheres than should have been possible given their formation histories. Others showed chemical signatures that suggested they had migrated vast distances from their original formation locations, picking up and losing atmospheric components along the way. Dr. Hannah Wakeford from the University of Bristol noted that Webb was revealing exoplanets as individual worlds, with their own unique evolutionary stories, rather than simple categories that could be easily classified and understood. Each planet appeared to be the product of a complex interplay of formation processes, migration patterns, and environmental influences that created genuinely unique worlds. The telescope's observations began to reveal that planetary systems are far more dynamic and varied than our own solar system had suggested. Planets migrate inward and outward from their formation locations. Atmospheres are stripped away and replenished through various processes, and the interactions between planets, their stars, and their environments create evolutionary pathways that produce extraordinary diversity. But Webb's most tantalizing discoveries came when it turned its attention to smaller, potentially rocky planets that might be capable of supporting liquid water and, possibly, life as we know it. The telescope's unprecedented sensitivity allowed it to detect atmospheric signatures from Earth-sized planets for the first time in astronomical history. The results were both encouraging and puzzling. Some rocky planets appeared to have retained thick atmospheres despite the intense radiation from their host stars. Others showed evidence of atmospheric compositions that could potentially support stable liquid water on their surfaces. Still others revealed chemical signatures that hinted at active geological processes that might maintain planetary habitability over long periods. The telescope detected water vapor in the atmospheres of several potentially habitable worlds, but not always in the amounts or locations that theoretical models predicted. Some planets showed evidence of water in their upper atmospheres, while appearing dry at their surfaces. Others seemed to have vast amounts of water vapor throughout their atmospheric columns. Dr. Laura Kreidberg from the Max Planck Institute for Astronomy described these observations as the first real glimpses into the diversity of potentially habitable worlds in our galaxy. Rather than finding Earth-like planets that matched our homeworld closely, Webb was revealing that habitability might take many different forms that astronomers were only beginning to understand. The telescope also began detecting more exotic atmospheric constituents that raised intriguing questions about the potential for life beyond Earth. Some planets showed chemical signatures that could be produced by biological processes, though they could also result from purely geological or atmospheric chemistry. The challenge lay in distinguishing between biosignatures, chemical indicators of life, and similar signatures produced by non-biological processes. Webb's observations were providing the data necessary to tackle this challenge, but the analysis required careful consideration of alternative explanations for every observation. One particularly intriguing discovery came from studying the atmospheres of planets in the TR-AP-PIST-1 system, 7 Earth-sized worlds orbiting a small red star about 40 light-years from Earth. Webb's observations revealed that these planets had remarkably different atmospheric properties despite forming in the same stellar system. Some appeared to have retained thick atmospheres, while others seemed to be bare rock with little or no atmospheric protection. The differences suggested that even planets forming in similar environments could follow dramatically different evolutionary pathways. Dr. Michael Guillon from the University of Liège, who discovered the TRAPPIST-1 system, noted that Webb's observations were revealing planetary evolution as a far more complex and unpredictable process than anyone had anticipated. Small differences in formation conditions, orbital dynamics, or stellar interactions could lead to vastly different outcomes for otherwise similar worlds. These discoveries about exoplanet diversity were forcing astronomers to expand their definitions of habitability and consider possibilities for life that extended far beyond Earth-like conditions. If planets could maintain complex chemistry under such a wide range of conditions, the potential for life in the universe might be far greater than previously imagined. But Webb's exploration of distant worlds was revealing more than just atmospheric chemistry. The telescope was beginning to detect evidence of active processes on exoplanets that suggested dynamic, evolving worlds rather than static objects frozen in their formation configurations. Some planets showed evidence of active volcanism that was replenishing their atmospheres with fresh gases. Others appeared to have magnetic fields that were protecting their atmospheres from stellar radiation. Still others showed signs of complex weather patterns that redistributed heat, a picture of the chemical compounds around their surfaces. The telescope was painting galaxy as filled with dynamic, evolving worlds, each following its own unique trajectory through cosmic time. Rather than the static, unchanging planets that astronomers had long assumed dominated the galaxy, Webb was revealing world-sations about planetary diversity, and evolution was setting the stage, for even that were actively shaping their own destinies through ongoing geological, atmospheric, and possibly biological processes. These reveal more profound discoveries about the nature of life in the universe and our place within the cosmic community of worlds. But Webb's most profound revelations were yet to come. As the telescope expanded its survey beyond individual exoplanets to examine entire stellar systems, it began uncovering evidence of processes that suggested the universe might be far more conducive to life than anyone had dared to imagine. The telescope detected what appeared to be massive reservoirs of organic molecules drifting in the space between stars. Complex carbon-based compounds that could serve as the raw materials for biological chemistry. These weren't just simple molecules, but sophisticated structures containing dozens of atoms, arranged in patterns that biochemists recognized as potential precursors to amino acids and other building blocks of life. Dr. Alexander Tylens from Leiden University, analyzing these interstellar organic detections, described the discovery as finding a cosmic pantry stocked with the ingredients for life scattered throughout the galaxy. The universe wasn't waiting for special conditions to create these molecules. It was producing them continuously through natural processes operating on vast scales. But the implications went deeper. Webb's observations revealed that these organic compounds weren't randomly distributed through space. They appeared to be concentrated along specific pathways and structures in the galaxy, following patterns that seemed to channel them toward regions where new planetary systems were forming. The telescope tracked these molecular highways as they flowed from dying stars towards stellar nurseries, carrying complex chemistry across hundreds of light years. When new planets formed in these enriched regions, they would inherit not just the heavy elements necessary for rocky worlds, but also the organic molecules that could potentially jumpstart biological evolution. This discovery suggested that life might not require the incredibly rare coincidences that many scientists had assumed. Instead, the universe appeared to be actively preparing environments where biological chemistry could develop, creating what some researchers began calling a cosmic biosphere that spans the entire galaxy. Webb's observations of star-forming regions confirm this hypothesis. The telescope detected organic molecules embedded in the icy grains that would eventually become incorporated into forming planets. These worlds wouldn't begin as sterile rocks that had to develop chemistry from scratch. They would inherit a complex molecular legacy from the cosmic processes that created them. Dr. Euwijn van Dissek from the Max Planck Institute for Extraterrestrial Physics noted that Webb was revealing a universe where the boundary between living and non-living chemistry was far more blurred than previously understood. The same processes that created stars and planets were also creating the molecular foundations that could support life. The telescope's infrared vision allowed it to peer into the cores of dense molecular clouds where new planetary systems were being born. In these cosmic cocoons, Webb detected not just the formation of planets, but the simultaneous development of complex organic chemistry that would become part of those worlds from their very beginning. Some of these molecular clouds contained what appeared to be natural laboratories, where increasingly complex compounds were being synthesized through processes that operated for millions of years. Cosmic radiation provided energy for chemical reactions, while the extreme cold preserved delicate molecular structures that would be destroyed in warmer environments. Webb tracked the evolution of these molecular clouds as they collapsed to form new stellar systems, watching as the organic compounds became incorporated into forming planets. The telescope was witnessing the universe's own version of pre, but perhaps most biotic chemistry operating on scales that dwarfed anything in terrestrial laboratories. Remarkably, Webb began detecting signatures of these processes in galaxies billions of light years away. The organic chemistry that could support life wasn't just a local phenomenon in our cosmic neighborhood. It appeared to be a fundamental feature of cosmic evolution that had been operating throughout the history of the universe. The telescope found complex molecules in galaxies that existed when the universe was less than 2 billion years old, suggesting that the potential for life had been present almost from the cosmic dawn. Rather than being a recent development in cosmic history, biological chemistry appeared to be as old as galaxies themselves. These discoveries forced astronomers to reconsider fundamental questions about the prevalence and distribution of life in the universe. If organic chemistry was this widespread and ancient, the number of potentially habitable worlds might be orders of magnitude larger. Pioneer in exoplanet research, described than previous estimates had suggested. Dr. Sarah Seeger from MIT add Webb's organic molecule detections as potentially the most important discovery in the search for life beyond Earth. The telescope wasn't just finding individual worlds that might support life. It was revealing that the entire universe appeared to be organized in ways that facilitate biological development. The implications extended beyond just the chemistry of life to include the physical conditions necessary for biological evolution. Webb's observations of planetary formation revealed that the processes creating new worlds were far more efficient at producing potentially habitable environments than theoretical models had predicted. The telescope detected evidence of water-rich planetesimals in forming stellar systems, suggesting that many existents with substantial new worlds would begin their water inventories. It observed the formation of planetary atmospheres in real time, watching as young worlds acquired the gaseous envelopes that could protect surface conditions and maintain stable climates. Some of these forming that seemed almost optim planetary systems showed characteristics sized for habitability. Planets formed at distances from their stars that would allow liquid water to exist on their surfaces. Larger worlds developed atmospheres thick enough to maintain greenhouse effects that could extend habitable zones. Smaller planets retained enough atmosphere to support complex chemistry, while avoiding the runaway greenhouse effects that could make them uninhabitable. Webb's observations suggested that the formation of potentially habitable worlds might be a natural outcome of stellar system development rather than an extremely rare accident. The physical processes that created planetary systems appear to naturally produce worlds with many of the characteristics necessary for life. This revelation connected to Webb's earlier discoveries about galactic evolution and stellar chemistry. The same processes that had enriched the universe with heavy elements and organic molecules were also creating the physical environments where those materials could support biological development. As we reach the end of our extraordinary journey through Webb's revolutionary discoveries, we find ourselves standing at the threshold of a new era in our understanding of the cosmos. From ancient galaxies that shouldn't exist to potentially habitable worlds orbiting distant stars. From the organized death of massive stars to the cosmic chemistry labs floating between stellar systems, Webb has shown us a universe that is stranger, more dynamic, and more conducive to life than we ever dared imagine. The James Webb Space Telescope reminds us that we are not mere observers of the cosmos, but active participants in the universe's ongoing journey of self-discovery. Each revelation from this extraordinary instrument suggests that consciousness itself may be the universe awakening to its own infinite beauty and potential. Sweet dreams, fellow travelers, as you drift through this magnificent cosmic dance. The universe continues to unveil its secrets, and we are here to witness every awe-inspiring moment. Wishing you a peaceful night, and I hope you enjoyed exploring with me here at Boring Science Channel. I'll see you tomorrow in the next video. Bye. Bye.